All right. As he said, my name is Jeff Young. I left my card there. Okay, that is my direct cell. All right, if you have a problem with one of these boilers, obviously you've got a great resource with Steve and his rep company. Got a great resource here at the wholesale location. But if you're having a problem they can't seem to solve, don't be afraid to give me a call. I also answer my phones on nights and I also answer on weekends. Okay, it's just a phone call. Part of the reason I do that is because I've sat where you're sitting. I started working for my first gas company in 1982, driving a bolt truck. Matter of fact, the bolt truck was sold, didn't even have a hose reel. You had to figure eight the hose in a bin in the back. Okay, I went from there to becoming a service tech, then becoming an installer. Did that for like 29 years. I went to work for a wholesaler, went to work for a rep, and I've been working for manufacturers ever since. So I've kind of covered every gambit of this industry as far as boilers go. These boilers are all I do at ECR. Okay, I handle just the condensing, wall hung condensing stuff. I've been doing that here. I've been here for about 6 years, but I probably installed 200 or 300 wall hung boilers when I was a contractor. Been working on them for a long time. Okay. With this boiler here, it's been out since 2013. There's no surprises left to it. If you're seeing a problem, I almost guarantee we've seen it already, and we can help you solve it. Quick show of hands. Has anybody installed any of these? Okay. Any problems with them? Any problems with them? You can say it if you had a problem with it. I'm okay with that. It can have a problem. Leaks? Leaks on the fittings? Oh, for the hydraulic separator, for the low loss header? Yep. Okay, so the brazes were leaking on that? Okay. Good morning. No, you're all right. It's a $15 fine. You can pay the guy in the back. As far as the brazes on those, just so you know, we don't sub those out anymore. Those are made in-house now in Utica, New York. We had more problems than just leaks. We actually had, what he's talking about is all these boilers come with a manifold, if you haven't installed one, to give you your primary, secondary out of the box. And it's just 3/4 pipes with T's to 1.5 or 1.25 depending on the size of the boiler, and they're brazed. So we've had issues where the brazes are leaking. So that's why we took it away from the company that was making them for us. We make them in-house now. We actually had one boiler, I went there twice, could not get water to flow through this machine, no matter what, brand new. Couldn't get water to go through it. We ended up finally taking the header off, looked down through the pipe, and where the 3/4 pipe meets the 1.25 pipe, they never drilled the hole. So that's why the water wouldn't move. So that kind of stuff can happen, okay? One of the things you're gonna hear me talk about a lot today through this presentation is that, nobody's boiler is infallible. Our boiler can break as well. It can. Our job is, if we have a failure, along with our partners, the wholesalers, and our reps, is to take care of that problem as quickly as we can to make you happy and make your customer happy. That's what it all boils down to. Any product can break. I don't care if you're putting in Navian or NTI or Bosch or whatever you're putting in, they can all break. Wiesmann, all great boilers, they can all break. Okay, it's how we respond to that and how we get you back up and going again that's going to keep you buying our product. Okay? Any questions throughout this, let me know. What I try to do with this, we have a big group here today, so it's going to be a little bit challenging. We're going to do about 20 minutes of slides just talking about the product. That's the only sales part of this presentation. Then we're all going to get up. We're going to tear down these 3 units right down to the case. We'll talk about what each part does, what error codes are associated with them. Then you're going to put it back together. Then after that, we'll cover venting, we'll cover gas line sizing, we'll cover wiring, cleaning and servicing, and troubleshooting we'll cover as well. All right, so this is a true technical course. Again, any questions on the way, please let me know. All right? Okay. Sizes. Okay, many different sizes. If you look at this, if you look at the boiler the way it is, the DCC is our combis, okay, and the DCB is our heat onlys. If you see an F, that's for floor model. If you see a W, it's for wall mount. So all our models come in a floor mount or a wall mount. From an installation standpoint, as an installer, I like the floor mount. From a service guy standpoint, I like the wall mount. Much easier to work on, okay? So they're the same boiler, nothing changes except when you have the floor mount, which is this one here, the pipes come out of the bottom. The wall mount, the other nice part about the wall mount is the side covers can come off if you need more room. What you're going to see if you haven't worked on these is there's a ton of room in these anyway, but the side covers are removable. They're not structural to the machine. It's built on a C channel, okay? So both side covers can come off depending if you have enough room in the little closet you might have installed it in this person's house or apartment, okay? Nice part about our models, that's just the BTU of the product. So when you see a 115, that's the max BTUs. 150, max BTUs. All right, so it makes it kind of easy to know what you're sizing. Okay. We're going to go over that. We do a tear down. Domestic hot water. How many people in here have put in combi boilers? Not necessarily ours, but have put in combi boilers. Have you ever had any complaints from your homeowners about domestic hot water through those combi boilers? What kind have you been putting in? No pressure. Reverend White, how about you? Boss, Green Star? Okay. Something to remember about these machines. If you go to somebody's house and they have a tanked water heater, or they have an indirect fired water heater on a boiler that you're going to change out, and you're going to go on demand, you really got to stress to that homeowner the difference between on demand and a tank, because the differences are big. I've had an on demand water heater in my house since 2000. The combi. Now, right now in my house, it's just my wife and I, because my kids are all grown up and out of the house. But we have a rule in my house. If someone's taking a shower, nobody runs any hot water in the house. Because although this machine will do 2 showers, if you're in the shower and someone turns on their shower, you're going to see a reduction in flow, you're going to see a reduction in pressure, okay, and you're going to see a change in temperature until that boiler can ramp back up and catch back up again, okay? That's one problem with on demand. Second problem is cold water sandwich effect. You cannot get away from it. You take a shower, you get out, okay? All the water in the pipe is still hot. The next person gets in. They turn the water on. It's hot, so they get right in, right? Well, it takes 12 seconds for that machine to light. So in that 12 seconds, a little bit of cold gets behind that hot, then the hot follows it. So the person ends up turning it on, turning on the shower, stepping in, stepping out, adjusting it, stepping back in, stepping out, turning it down now because it got too hot, all right? So there's a little bit of a training process there. We're seeing a very big change in industry right now where a lot of guys are going back to a heat-only boiler and an indirect fired water heater. You know, 12 years ago when you had tank water heaters and indirect fired water heaters, what was the big selling point of an on-demand? You're not heating water you're not using, correct? That was the big selling point. And you have endless hot water, all good points. But now, the tanks that even we sell, our H2O tanks, any indirect and any tanked water heater has an R value that's so high that you lose about a 30 degree an hour of standby loss. That's it. So that machine's only gonna run maybe a couple times a day to maintain that tank. So if you have a person who has 2 bathrooms, 3 bathrooms, especially 3 bathrooms, an on-demand wouldn't be for them. You really want to, at that point in time, look at putting a heat-only one in, size it indirect properly, they'll never have any problems. The other problem I see is that a lot of houses, new houses, want to have whole house recirc systems in. So they're not waiting for the hot water to get there. You can't put a recirc on an on-demand boiler. Okay, the only company that does that, I think, is Navian, because they build the recirc into the boiler. Okay, you can't, because if you put a recirc pump on here and you put it on a timer, or you put it on an aquastat, okay, the whole time that pump is running, you have no heat, number one. Number two, the boiler doesn't know how to think when you're bringing 120 degree water back to the domestic side. It's not used to that. It's used to bringing 50 degree water or 60 degree water, or where I live in Vermont, my well that I have in the ground in Vermont where I live in the winter is about 41 degrees, the water coming out of the ground, okay? So just keep that in mind. If you ever have a question, call us. Call Steve, call the wholesaler, call me, we'll help you, all right? I think it's surprising. I've gone to job sites with contractors before where they want to use our boiler for a certain application. I go and look at it and I tell them no. And they look at me like I'm crazy. Well, you don't want to sell a boiler? I do want to sell a boiler, but I don't want to sell a boiler where we're going to have a problem, because eventually your problem becomes my problem. And I don't need any problems that are because we didn't do the right thing, put the right boiler in the right spot. Okay, and that basically boils down to anytime you do anything beyond the limits of the boiler. If I run my vent too far, that's beyond the limits. If I try to make my gas pressure too low, that's beyond the limits. So there's a lot of things to keep in mind when putting any of these wall hung boilers in, okay? Second thing is water quality. If you're gonna put an on-demand water heater in somebody's house with a driven well, you should have the water tested first. If they've got 27 grains of hardness and they don't wanna soften the water, sell them something else. Sell them a heat-only boiler and sell them an indirect, okay? Because we can handle 12 grains of hardness with this machine. But after 12 grains of hardness, you heat hard water, it calcifies, that calcification gets in the flat plate, gums it up, now the machine won't run properly, okay? So keep that in mind as far as water quality goes too. And I have guys tell me all the time, well, city water should be fine. Well, yes, city water should be fine, but I've tested city water where I had 18, 19 grains of hardness. You know, I've had people say to me, well, doesn't the city have to make sure that water is good? Well, they're supposed to, but I think if you talk to the people in Flint, Michigan, they're going to tell you a little different story, aren't they? About what they have to do to the water that they're drinking in their homes, okay? You can see the 2.5 gallons a minute, 3.5, 5 gallons a minute. That's what these machines will produce, our combis, all right? Be very careful of our 205. Well, one of the things with our 205 that we see is people want to put it in their house because it says it'll give you 5 gallons a minute. All right, so they put it in the house, and now they have 3 zones of heat. One of the zones is a 7-foot piece of baseboard in the mudroom, and you got a boiler that's running at 165,000 BTUs. So it starts to overheat the boiler. Okay, and over time you'll start getting 110 error codes, and so it's really about sizing it properly for the job you're doing. And this number here, this 70-degree rise, it's a great selling feature, but the temperature rise doesn't really matter with these boilers because it's a fixed flow. This little piece right here is my filter assembly, and I'll pass it around. And if you pull this little filter off there, you'll see a flow restrictor in the bottom of it. That's how we keep 2.5 gallons a minute, 3.5 gallons a minute, or 5 gallons a minute. So whether it's a 70-degree rise, a 20-degree rise, an 80-degree rise, you're getting 2.5 gallons a minute, or 3.5 or 5. You'll also see when I pass this around, because I talk about water quality, you'll notice when you look at this, there's an impeller in there that couldn't spin anymore because the mineral buildup was so bad on it, it plugged it up solid. So you'll see that when it comes around to you, okay? Any questions about domestic? I know I spent a little bit of time in that because I will tell you that probably 70% of all the calls that come through our tech line are for temperature fluctuations at a fixture. Yes? Filters are fine, but if not, if you have hard water, because the filter is not going to soften the water or treat the water. It's going to take any, depending on the filter you have, it's going to take any sediment out of it or any, that kind of thing out of the boiler, but it's not going to change what's in the water itself. Okay, now there's companies like AquaPure makes a filter. It's a little filter that can put on a cold water. It's got a chemical in there that doesn't soften the water, but it treats all the copper and the fittings inside the boiler so that the hardness can't adhere to it. And I put quite a few of those in when I was still a contractor, and they seem to work okay. But the bottom line is if they're 24, 25 grains of hardness and they want to soften the water, you're kind of asking for trouble at that point in time. Carbon filter, again, if the carbon filter can do anything as far as the hardness of it, you know what I mean? Carbon filters and that kind of stuff would work good for iron. If you had there's like 7 different kinds of iron you can have in your water. There's water soluble, there's mineral. So as far as a carbon filter, again, it all depends if it's hardness or something else in the water. Yes, if you look in the manual, the manual comes in a box. It tells you to put a mixing valve, use it as a tempering valve on the machine. It's external, that's correct. And here's the reason why. In the summer, you will have no issues because the boiler is not running for heat. But in the winter, if the boiler is running for heat, and let's say the boiler temperature in the boiler system is 170 degrees, you have a call for domestic hot water. The 3-way valve opens, that 170-degree water hits that flat plate. Flash heats the water in the flat plate to the point where it'll climb to about 145, 150 degrees. The burner will shut off, then it'll relight again, and it all takes about 55 seconds, okay? So the temperature, when we talk about the mixing valve, the temperature, you can use a Honeywell, Caleffi, whatever you want to use, okay? But what you want to do is you don't want to set the boiler for 140 and set the mixing valve for 120 because you're not mixing, you're tempering. So you set the boiler, the domestic for 120, set your mixing valve for 120. It just gives you that protection in case the water got to 140, 145 degrees, it wouldn't get to the fixtures and scald anybody, okay? Now, the part I don't like about that, obviously, is you're putting another mixing valve in the system. And we all know that those mixing valves, I don't care who the manufacturer is, they last about 5 or 6 years. That's about the lifespan of those mixing valves. And then they start to give you temperature fluctuations through every fixture in the home because the mixing valve's not working right, okay? But yeah, if you look in the manual, there's a whole section in the manual about putting that mixing valve on the hot water out to make sure it's an anti-scald device, okay? Anything else about domestic? Okay. Just a quick thing about turn down. That is the biggest buzzword in the industry now is turn down ratio. Everybody always hits me with it when I go to these training classes because I show them ours and we're 5 to 1 to 7 to 1. And the first thing someone will say to me, well, I put the Navi in and they're 10 to 1. Yes, they are. They're 10 to 1. But you got to understand what turn down ratio is. Turn down ratio is just your high fire divided by your low fire to get your turn down ratio. So in order to get a 10 to 1 turn down ratio, they're using a machine that's 199,000 BTUs in high fire and 18,000 BTUs in low fire to get their 10 to 1, okay? It doesn't increase your efficiency. The only way I can increase your efficiency would be if I could take my low fire modulation rate and turn it way down to, let's say, 3,000 BTUs. We can't do that. Nobody can do that on these pieces of equipment because with the negative gas valve, we can't keep the flame sustained at that low of BTUs. So we're all limited in that regard, no matter who the manufacturer is. All right, so turn down ratio is just high fire divided by low fire to get your turn down ratio. I think the next generation of boilers we're looking at coming out with the few changes we're going to make is we're going to up the high fire BTUs and lower the low fire a little bit to get to the 10-to-1 so we match everybody else, so we haven't got to hear it anymore, okay? So those are the sizes. I won't spend a lot of time on this. Like I said, pretty easy to figure out. The BTUs are the same as what the model number is. Keep in mind that your BTUs on the combi units are 205, okay, 205,000 for domestic, 165,000 for central heating. They always raise it higher for the domestic than they do the central heating, okay? And then, of course, a little bit bigger with the dimensions of the boiler itself and the weight of it, okay? All right, kind of a neat little video we have here. One of our engineers in Utica cut away the plastic housing of the heat exchanger. So you can kind of see how the burner works when the burner comes on and how it heats the different parts of the heat exchanger itself. The burner just lit. Now you'll notice that you only really see a flame to about here. It's because the burner's little. Okay, they do that on purpose because your cold water, the return water is on this side, supply goes out this side. So the longer we can keep these pipes a little bit cooler here, the more we condense, the better our efficiency. Okay? When we start talking about our efficiency on these machines, keep in mind, just because the box says 95% efficient, you're not going to get 95% efficiency all the time. Nobody's boiler is. Okay? It's all depending on return water temperature and what a return water temperature is. So if you have in-slab radiant in somebody's house and you're running that at 114 degrees water temperature, you're going to be running at 95, 97% efficiency all the time. But if you have thin tube baseboard in the house or high temperature heat in your house, on high fire, you might be running only at 89, 90% efficiency. Can't tell you how many houses I go to where I put my combustion analyzer on somebody's boiler and the homeowners there watching me and they watch the efficiency and it says 89%, and they say to me, well, how come it's not 95? And then I have to explain to them about, how water condenses, getting down below the dew point and all that kind of thing so they understand. Now you see it's getting a little bit hotter. It's getting to the whole heat exchanger now. And then the burner just went out. So just kind of a neat way to see what actually goes on inside that heat exchanger when the burner comes on and runs. And obviously much quieter than that because when the front cover's on there, the decibel level of these, you can stand right next to it and not even hear the machine running. So you can hear a lot of fan noise and stuff with that. Okay, 3 quick videos. They're all about the front control. The front control in this machine does a lot of stuff. All right? Just like everything else today, I'm going to throw a lot of stuff at everybody here. You're not going to remember all of it, and that's okay, because that's what Steve and I are here for. All right? Again, if you ever have any questions, don't be afraid to give us a call. But we're going to talk about what the front control can do in the next 3 videos. Then we'll talk about it.
Today we'll look at the functions and display of the control on your boiler. The first button we'll address is the Power Reset button. This is the only button that serves a dual purpose. If you press and hold it down, it will power off the unit. The screen will flash and only the power icon will be on the display. Holding the button down again will power the unit back on. This button is also used to reset error codes. With an error code on a display, a short press and release will reset the error code. The IP button will give you information on the boiler, including supply and return temperatures, domestic and central heat set points, fan speeds, outdoor temperature sensor readings, and a variety of other helpful information. To adjust your domestic hot water temperature, use the plus and minus buttons with the faucet icon on them. The default temperature is set to 120 degrees. To adjust your central heating supply temperature, use the plus and minus buttons with the radiator icon on them. The default max temperature for your heating loop is 176 degrees. This cannot be increased. You can decrease it to the temperature you need for the heating elements in your home. For example, if you have an air handler, you can turn it down to 140 degrees, or if you're using radiant floor heat, you can lower it to 120 degrees. The center button is what we call the summer-winter mode, or the boiler operating mode button. If the button is pressed with the faucet and radiator icon lit on the display, the radiator icon will disappear. The unit is now in summer mode and will not allow a call for central heat. Pushing the button again, the faucet icon will disappear and the radiator icon will be displayed. In this mode, the unit will only call for heat. Press the button again and both icons will appear on the display again for normal operating mode. In the instance where a customer may have inadvertently changed this setting, and is no longer getting either heat or domestic hot water, check to see what mode the boiler is in. Now we will look at the display itself. If there is an ignition fault, this icon will flash. A boiler fault requiring service will flash the wrench icon. If the boiler water pressure drops below 7.25 psi, this icon will flash. The R icon is for a manually resettable fault. E is for a fault in progress. I is for the information menu. P is the programming or parameter menu. The right side of the screen will display Fahrenheit and PSI, the default units out of the box, or Celsius in bars. If the flame icon is on, the burner is lit. If the faucet icon is flashing, there is a call for domestic hot water. And if the radiator icon is flashing, there is a call for central heat. The last icon is the power indicator. If the boiler is off, only this icon will be displayed in the lower right corner of the screen. If you have any other questions, please refer to your installation and operation manual that comes in the box.
That power reset button, we get more calls on that button because it does two purposes. Okay, somebody will have an error code in the front of the machine and they'll press that button and they'll hold it down for 6 seconds and it shuts the boiler off. When you have an error code, it's a 2-second push. 1, 2, and let go, almost like a doorbell. That'll reset the error code. You hold it too long, it shuts the power off to the boiler. We get those calls quite often. Okay. Now, if you do a 2-second push and it doesn't reset the code, that's because whatever code you had hasn't been resolved yet. If it was a bad sensor, the sensor hasn't been resolved. If it was something else going on, it hasn't been fixed. That's why the error code won't go away. Okay. And that's that button here. We'll be covering the boiler information menu. This menu gives you very helpful information on troubleshooting and maintaining your boiler. To access the information menu, you press and hold down the IP button until the screen displays 00. You now have access to the first piece of information, which is a secondary fault code. Some of the error codes in the boiler have different phases to the code. This will give you that phase. For instance, if you had a 25 error code, there's 3 different phases to that code: 500, 525, and 535. That would be displayed where the 000 is now. If I press the IP button again, I can see 01 of the information menu. This displays the heating supply temperature of the boiler in real time. So if you want to see what the supply temperature is coming out of the boiler to your heating system, this will let you see that. 02 is the outdoor reset sensor. If you have an outdoor reset sensor connected to the unit, the current temperature reading would be displayed here. Right now we see 3 dashes because there is no outdoor reset sensor connected to this unit. 03 is the indirect tank sensor. If you are using an indirect tank water heater with a heat-only boiler and the indirect tank kit, this function would give you the temperature inside the well of the tank. 04 is for a combi or combination boiler. If you're using a combi boiler, this will tell you the temperature of your domestic hot water being provided by the boiler in real time. This is very useful for homes where you may be getting temperature fluctuations at fixtures in the home. 05 is the current water pressure inside the boiler. 06 is the heating return temperature. So you can access this information menu and look at 01 and 06 to compare your delta T going across your boiler at any time. 07 is the thermal fuse status. 001 means it is active. 08 is currently not used. 09 is the heating set point of 176 degrees out of your heating loop. 10 and 11 also are not used. They are manufacturing functions. 12 is the flue temperature sensor. This will tell you the reading of your stack temperature. 13 is another manufacturing function. 14 is for open therm communication. 15 and 16 are more manufacturing functions. 17 will show you in real time the RPMs of the blower inside the boiler when it's running. 18 is the last one, which is another manufacturing function. After that, it cycles back to the beginning. To exit the information menu, press the power reset button one time and you're back to the main screen. If you forget to exit the information menu, after 5 minutes, the boiler will revert back to the main screen on its own. Again, these are things that you won't use a ton. Matter of fact, you probably use them more if you called me than you would on your own. Because if you call me with a certain problem, I'm going to walk you through a lot of stuff on the phone so we can figure out what's going on with the boiler. But it does give you a lot of good information. You think about, well, why would I have to know the RPMs of my fan? Well, if I know that my low fire fan speed is 1180 RPMs, and I know my high fire fan speed is 5800 RPMs, if I look there, I can see where I'm modulating at any given point in time in the boiler. Give me an idea what my fire rate is, okay? The one I use the most is number 4 on a combi boiler. Let's say you get a call from a customer. They say they're getting temperature fluctuations at their fixtures. First thing I always do is I go to the house, I turn on just a kitchen sink or a bathroom sink, I go downstairs, I go to number 4 and I watch my temperature. If my temperature stays consistent, 120 degrees plus or minus a couple degrees, then I know that we're making the right domestic hot water. So if all my sinks are good, but my shower is not, my shower overheats and shuts off and overheats and shuts off, now I know I have a plumbing problem. Most of the time, it's a pressure balancing valve cartridge that has failed inside the valve itself. I changed mine about every 5 years in my house. And 13, 14 years ago, all the manufacturers, when Rinnai first came out with their continuum water heater, their first on-demand water heater, they actually had a special cartridge. Moen, Delta, they all made a special cartridge for on-demand. A lot of manufacturers now, you can't even replace the cartridge. Last time I had to replace mine, which was 2 years ago, I couldn't get a replacement cartridge for that Delta faucet anymore because they weren't making it anymore. So I had to buy a whole new faucet, put that in. So it can happen. But knowing, if I go to that same house and every fixture does the same thing, then I know it's a boiler problem. But if only one fixture does it, it has nothing to do with the boiler at that point in time. Okay, so information button gives you a lot of good information. Okay, why it's called the information button. And you got all that, right? Because that's on the test later. There's no test. Well, except for the guy sitting in the front. They haven't got to take the test. Everybody else takes the test. Today, I will show you how to find the error code history of your boiler. The first step is to access the parameters of the boiler. To do this, press and hold down the radiator plus and minus buttons until the screen displays P01. You are now in the parameter mode. The error code history begins at parameter 32. Press the radiator plus button to advance parameters. In this case, we can hold down the button to advance parameters quickly to 32. Once there, 7 different numbers will flash on the screen. The first one will be C00. This is the error storage number in order from C00 to C09. The second number flashing is the actual error code. The third number is the consecutive error code counter of the same error. This tells you how many times consecutively this error has occurred. The fourth number tells you how many days have passed since the error. The next number is the system status, followed by the system phase, and finally, the temperature of the boiler at the time that the error code occurred. Now the beauty of that is you have a homeowner that tells you they've had 4 error codes yesterday. Well, you can tell exactly how many error codes they had yesterday because it's going to tell you how many they had yesterday. It's no different. That's the same thing. If everybody here does oil as well, what's the first thing you always ask? How many times did you press the reset button? Right? Did you only press it once? Yeah, I only pressed it once. And you look in there and there's just a gallon of fuel oil on the bottom of the chamber. Okay? So the nice part of this is it holds 9 error codes. All right? So it tells you what the error code is. The consecutive counter is nice because if I have the same error code, it doesn't take one away and add one. It just adds it to the counter. So if I get there and I look at the consecutive counter and the counter says 6, that means that error code happened 6 times. Okay, and then it tells me how many days have passed since it happened. We can hold up to 4 months of data in here. So if you go there and it says 99, that means the error code happened over 4 months ago. So it's not really relevant at that point in time. All right. The system and the status and the phase, that tells me, was the boiler in domestic hot water mode? Was it in heat mode? Was it in standby mode? And then lastly, the temperature in the boiler is important because if I've got a 110 error code, which is overheating of the boiler water, then that number should be around 235 degrees. So it gives me a lot of information. You'll find if you ever called me at a job site, and depending on the problem we're having, I'm going to have you go there. I'm going to have you read all those numbers to me. I'm going to write them all down as you read them to me. And that's going to give me a really good snapshot of what's going on with the boiler at that particular point in time. And usually we can solve the problems. Again, this is not a new boiler. It's been out long enough where all the bugs are out of it. They really are. Again, if you're going to see it in the field, I almost guarantee you we've already seen it. And we've made corrections and changes to make sure we don't see those things anymore. Okay? All right? I can then press the Radiator Plus button to advance to the next error code, C01, and it will show the 7 different numbers for that error. This boiler can store up to 10 errors. Continue pressing the Radiator Plus button to access errors all the way to C09. Now C00 through C06 are what we call anomaly codes. These will not register on the front display and do not require a soft lockout or a hard reset. C07 through C09 are your hard lockout errors. Those are the ones that require a reset button to be pressed. To exit the parameters mode, press the power reset button one time and you will be back to the main screen. In the service manual, there is a page you can print listing the parameter numbers and error code number descriptions so that you can log the numbers as they flash. You can also write them down in your own log to reference later. If you have any other questions, please refer to your installation and user manual that comes in the box. For central heating and for domestic hot water. So basically it walks you through each one. You find what error code you have, you follow the steps, eventually it tells you go to section F. When you get to section F, it's going to tell you, okay, you have a bad sensor. Let's do an ohms test on it. You should have 3 to 5 ohms on it or microamps, whatever you have to have. So it really gives you a lot of information. Now, do you guys look at this very often? No. Most of the phone calls I get, I'll get a phone call from a contractor and I said, okay, what's the problem? He goes, I have a 133 error code. Okay, what have you done so far? Well, nothing, I called you. Okay, well, that's fine. But, you know, if you have a 133 error code, which is a flame failure, you can do the basic stuff like making sure you have, I don't know, gas, you know, making sure you have, I don't know, power, you know, making sure you have spark. You know, there's some things you can do. But a lot of times, most of the calls I get are that way. You know, they'll call me up and say, I'm having this problem. What do I do? And I get it. Like I told you, you guys have to remember how to fix hundreds of different products. I work on one. Okay, so you can sit through a class like this and you're going to gain some stuff out of it and you're going to take away some stuff out of it. But you're not going to, you know, it might be a year before you stand in front of one of these. Okay, that's why we give you the phone numbers. Again, don't be afraid to give us a call and we'll help you with any of that kind of stuff. Okay. All right, come on up. We got 3 boilers. We need some volunteers to start ripping into them. Maybe some guys can take them apart. Some guys can put them back together. This is not a test. It's not any pressure on anybody. It's just a way for you to understand how these machines work. Nice part about these machines is the tools you see on the table. A Phillips head screwdriver, a 4mm Allen wrench, a 10mm wrench, an 18mm socket, and an adjustable wrench is all you need to take this machine to be completely apart. Okay? Come on up. Even if you don't want to take it apart, at least we can be up here because we're going to talk about a lot of stuff while we're doing it. Okay? Nope, just pull the door down. Yep, just grab the white door that drops down first like this. Okay? Go ahead and pull your white door down. And you guys pull your white door down as well. First thing I want you to do is you have an orange spark cable. You don't have one. It was missing after my last class. I guess somebody needed it more than I did. So pull this red cable off right there and pull this red cable off right here. Pull it right out of the box. Pull it right out of the box itself. This is your spark cable. Can I see it for a second? Right here. All right. 15,000 volts, just like a spark plug. All right. If you actually have a spark plug tester, you can go to Harbor Freight, buy them for $4.99. You can put that tester right on here, plug it in line, and it will light up as that machine starts to spark, which is a nice little feature. If you have a 133 error code, this is the first thing I check after I check my gas pressure. Okay. I'm looking for this cable right here. You see the end of this? If you can wiggle it like a loose tooth, you have a broken cable, and that's why it's not lighting. You'll also see when that happens, where it plugs into the board, there'll be burnt spots on the plastic. The other thing that can cause it is if my spark gap goes too far apart. Because when my spark gap goes apart, what will happen is the spark will go from the porcelain to the ground because it's looking for a ground. So if you go to one of these machines and you have the front cover on and you fire it off, and you can hear that sparker going snap, 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 something's wrong. You shouldn't be able to hear the sparker with just the front cover off. Okay? All right, go ahead and unplug your ground wire and your flame rod, the white wire. So unplug this and unplug this. So the ground wire and the flame rod wire, pull those out. Okay, very good. Now, You see the corrugated tube that goes from the gas valve to the fan? Pull the clip off, which you don't have a clip. Just pull it out, pull the clip off, and pull that out of the fan. Okay? Once you've done that, disconnect the two connections on the fan. You have a 3-prong connection and a 5-prong connection. Unplug those. Take the plugs off. Once you've done that, take your 10mm wrench and take these 4 10mm nuts off the front face of the boiler and pull the burner out of the machine. Now, yep, right there. So you should have a 10mm. Now, if you were going to service this machine, clean it and service it, this is what you would do. This is how you would get to the heat exchanger, is what you're doing right now. So right here. Here. You're missing one. So don't worry about that. Go ahead and pull these off. The 10mm. Yes, you want to have the power off first. Yes, unplug it out of the wall. That's correct. I think about that, you know, and you say that it sounds funny, but you're not wrong. You're not wrong. It's what? The boiler itself, this is about 100 pounds. And probably 60 pounds, that 100 pounds is the heat exchanger itself. It's a 316L nickel chrome plated stainless steel heat exchanger. Yep, once you do it, pull the burner right out. And now you have full access to the heat exchanger once you pull that out. Can I see yours for a second, please? All right, this is what you're looking at, okay? Now, you see your sparker? You always want to check your spark gap on that. Make sure it's not doing this, starting to go away. I have seen that before where the spark gap will go away. You'll start getting that snapping noise. Overfiring usually is what we found, okay? We see it more on propane than natural gas. We see everything more on propane than natural gas, including the white buildup on the flame rod. Typically on natural gas, you won't see the white buildup, that white powder, but on propane you will because it's a much wetter fuel. Okay, for every 100,000 BTUs of gas you burn, you make a gallon of water. Keep that vapor hot, it goes out as a vapor, cool it, turns back to water. If you do pull that off and it's got a white buildup on it, just take a dollar bill and clean the white powder off. Don't use any kind of steel wool, cleaning cloth, emery, it'll scratch it. If you groove it, you change the resistance and it won't rectify flame anymore. If you want to check your rectification, you'd unplug this, take your voltmeter, put it on microamps, put one probe there, put one probe in the cable, and fire it off. As long as you have between 3 and 5 microamps, you know your flame rod's reading okay. Okay?
Does this have to be pure, because on like furnaces and stuff like that, these proof ground? So your flame sensor has to be, I mean, it can't be wiggly.
No, and this wouldn't be affected as much with that because the ground is, the vessel's grounded. But yes, if it was too loose, you could not. But what we worry about more than that is we're sucking air in through there or blowing air out through there. Okay, but yes, you want to make sure those are tight, and there is a gasket underneath there as well. The fan, okay, the fan itself, 160 error code. If you get a 160 error code, the first thing you're going to do is unplug the 5-prong connector off the machine with the power on, but it's still plugged in. Just unplug that. If the fan goes to full RPMs, replace the fan. If the fan doesn't go to full RPMs, check for 120 volts here. You might have a bad board, not a bad fan. Most of the time, it's the fan if you're going to have an issue. You get a 160. When you look at this fan, okay, underneath here is another impeller. Inside that impeller, there's a magnet molded into the plastic. So as it spins, a Hall sensor picks up the revolutions. That's how we read it, okay? So there's a whole other secondary PCB board inside here that can go bad, all right? So if you get a 160, always check for 120 volts here, unplug that. If it goes to full RPM, if you're still getting 160s, replace the fan.
Is that a common issue?
It is not. The fans are they're made by EBM. EBM makes the fans for almost every manufacturer out there. So they're pretty reliable fan, okay? The nice part of these boilers, the 75,000 BTU to the 150 is all the same fan. The only different fan is on a 165 or 205. They're a little bit bigger. The only difference is if you have a 75, you're going to take this venturi off and put it on the new fan because the venturi is made for each different size of the boiler that you have. That's the nice part of this boiler. Sensors, relays, 3-way valve motors are all the same on every model. So basically, if you had 25 parts in your truck, you'd cover every part for every model of boiler we sell in this line. Okay, so it makes it kind of nice. You haven't got to have a 1,000 different parts in your truck to take care of that. Okay, any questions about that? There you go. Okay, take your 4mm Allen wrench and pull the head of your pump off the face. Now, if your pump goes bad, you're going to get a 125 error code. Now, that could mean you're not moving any water, okay? Or it could mean that you have a supply return sensor that's not reading properly, because you have a supply return sensor on this machine. Okay? I think these are all combis. If they have a flat plate in the back, they're a combi. Okay? Now you'll notice there's a little silver screw on the front of that pump. You can actually remove that silver screw with water in the boiler to see if the pump is actually spinning, because the impeller pin is on that side of it. I'm sure if you've been to a Grumpus class, they give you that nice little magnetic spinny thing that you put on there and it tells you if the pump is spinning or not. They're fine, they're cute, but they don't always work. I've had ones where I put it on there and it spins and I pull the cap off and it's not spinning. Okay? Now, let's say you had one of these pumps, right? And it's a weekend and the pump's seized up and you don't have one. Go grab a 1558 Grumpus 3-speed manual pump in your truck, put it in there, it'll work. It'll get them by for the weekend, okay? You don't want to leave it in there long term, it'll get you by. I've never tried a Takeo. I've only done the other Grumpuses, and the Grumpuses work fine. The nice part of the Grumpus is they all have this cutout on the top of the plastic body. So you can actually pull this off, undo the wires, knock the knockout out on the 1558, and put the same plug back in it, so it plugs right back into the boiler again. Okay? So keep that in mind. Again, that plug in the front. If you put one of these in for the first time you've ever put one in, before you put water to it, take this cap off, give that impeller a spin. These sit like this in storage. So sometimes when they sit like that, the impeller will kind of get weighted down. So when it goes to start up, it won't spin right away. Okay, you got to give it a little manual spin and it takes off and it runs. Okay? Now this is a 2-speed pump. It does it automatically. When I say 2-speed, it's minimal. This is 4 gallons a minute, 7 feet ahead out of the box is what it'll give you. All right? Low speed is 3.6 gallons a minute with 5.8 feet ahead. So it spends most of its life on high speed. Okay? Questions about that? No. Good. Go ahead and take the plastic body off there now. There's a one on the bottom, one on the top. So take your whole plastic body off. There's a screw here and a screw below. Now, if you have to replace the pump, the new pump's going to come with the plastic body. I never take the plastic body off if I don't have to. Because if I don't have to interrupt any O-rings, I don't want to interrupt any O-rings. So if you have to replace the pump, just pull the head off, put the new head on the old body, and you'll be fine. Okay? There you go. Good. Yep. One on top, one on bottom. You got your high vent on there. When you put this in for the first time, open the high vent when you're purging. When you're done purging, close it. Don't leave it open. Okay, I don't care whose high vent you have, ours, any aftermarket high vent you buy, over time, the floats start to seat. They won't work properly. You start getting water leaking out of the top of them. How many times have you gone to a brass one where it's all green because the water's leaking out of it? If I can leak water out, I'm sucking air in. So once I purge this, I always close that. I don't leave it open. You're going to have some kind of air elimination on the boiler anyway, typically a spiral vent or something like that, to get rid of the air in the whole system. Yeah, when I first fire it, when I'm purging it, I'm going to have it open to get the air out of it. But once I get it all purged, I'm going to close that down and not leave it open. Okay? All right, that corrugated gas line, remove that off the top of the gas valve, please. And when you pull it off, there should be an orifice in there. Should be. Because that gas valve is the same valve for a 75,000 BTU and a 205,000 BTU. It's the same gas valve. There you go. Yep, right there. So when you pull that out, you have an orifice in there. So that's how it changes it. Now, you never got to change this orifice. Doesn't matter if it's natural gas or LP. It's not a different orifice. This requires no conversion kit. Okay, when you go from one fuel to another, it's just a fan speed adjustment and an auto calibration. And it takes from one fuel to another. Matter of fact, when you fire this machine off for the first time, which I'll show you in a video a little bit later, it actually determines what kind of gas you're burning all by itself and converts itself the first time you fire it off. So pretty smart machine. Okay? There is not. I always have the green part up, but it's not. It doesn't matter. If you put it black side up, it's still going to run just fine. Okay? The only thing you're going to notice different on the bigger ones, it'll have a different stamp, a bigger orifice. That's all. Okay? All right? Okay. On the left-hand side, you have a black motor with a clip in it. That's our 3-way valve motor. Remove the clip and take the motor out of that body of that valve. There should be a U-clip on the bottom of it. You can see it down there, that little black clip. Just give it a pull. Take your motor right out. You can unplug the motor, unplug it out of the machine. Okay, this is your 3-way valve motor. So what it does, basically, if you put your finger in that valve you just pulled that out of, you're going to see there's a pin in there that you can push up and down with your finger. When the pin is down, you're in central heating mode, so the water is diverted to the heat loop. When the pin is up, you're in your domestic hot water mode, so the water is diverted to the flat plate heat exchanger. That's how that works. Now, let's say again, you got to a job site. You had to call for domestic, but the heat wouldn't work, okay? You pull this motor out, and you notice that the pin will not come back down, the motor shot. Take a dime or a penny, put it right there, push it down, lock it in. Now they have heat for the rest of the weekend. Now they don't have any hot water unless you show them how to pull it out, but you can at least get them heat for the rest of the weekend until you can replace that valve, that motor, okay? If you're in domestic hot water mode, you'll notice there's a little brass piece there, or sometimes a little silver piece that's in there. That will be up. You can, matter of fact, if you shake it, it'll go back and forth. You can hear it rattling inside there. Okay, I'm gonna try hard not to spit on you. All right, now take your adjustable wrench and pull that valve with the pin in it. Pull it right out of the machine. So that valve you just push down here, take that right out. Yep. It can, but I've seen it fail in both positions. It depends on water quality, and that you're going to see in a second when they pull these out of here how it works. Okay. Nice part about this is if you have to replace that, you don't have to replace the whole valve. It's just the internal cartridge you have to replace. Doesn't want to come out? Somebody got in there nice and tight? That's a rarity. There you go. That's how it works. So when you look at that, when you push that, so when I told you it was down, right? So now the water can go through here to go to the heat loop. And when it goes the other way, now the water stops going there, but goes through there to the flat plate. That's how that whole valve works. If you ever have one of these that you go to the house, when the domestic hot water is running, the machine's squealing, making a squealing noise, it's because one of these rubber O-rings has failed. And it's making it flutter when the water goes through it. So you replace that. And yes, when you replace this, you have to drain the boiler. Okay, another one of those obvious things you should know, right? And that's how that works. There you go. Yep. So same thing for you guys. See, if I push that, you can see it. It just changes position. That's all it does. Okay, back and forth. All right, you guys got yours out okay? No, you took your water pressure switch out. You're jumping ahead. That's it, you're fired. Just pull this out right here. Take your adjustable wrench and unscrew that out of the top of there. Well, you will eventually, but just jumping ahead, so you're fine. All right, now pull this little plastic piece off right there. Right here. Pull this little plastic piece off the top of that valve. Just pull it off. Yeah, just kind of give it a little bit of it'll come off the top. It's got a little catch in it, but and go ahead and unplug it. Yep, go ahead and unplug that. And now take your 18 millimeter, just give it a pull. It should just pull out of there. There you go. Now take your 18 millimeter socket and pull that out of the top of that valve. You guys too. Let me sneak up by you here for a second. How we doing? Get it on the flat, like this. Get it on the flat part of that, like this.
Oh.
Okay, it's going to give you more leverage. Okay.
Gotcha. Okay. All right.
You said if you can't push that in, it's bad.
No, if it like yours right now, that would be the domestic mode. See, I can make it rattle. So if you look at this little thing on the end, see there's like a little steel piece in there?
Yeah.
When it falls all the way down in there, that's for domestic mode. But it should be all the way out on heat mode. So if you're in the heat mode and you pull this out and it rattles still, that's because the motor shot. Okay?
All right.
All right, you got that out?
Now we got the right part.
Okay.
Gotcha.
All right, and again, you can see how that works with the pin. So if I push the pin, so right now, it can go through that part.
Yeah.
When the pin pushes down, it can go through that part. And that one's really stiff. You know what I mean?
Like a damn thermostat.
Kind of, yes. Almost like a thermostat in a car, yes. Yep. All right, now take your this and pull that right out of there. Okay, where's the filter assembly? Who's got one out? All right, and where's your little hull sensor that you took off there too? So I passed that around so you can see it before. This is just an impeller inside here. As long as you have a half a gallon a minute of flow, that impeller is going to start spinning. And the top of that impeller is a magnet. As the magnet spins, it puts this hull sensor light, sees it, lights up, tells the three-way valve to change position, and puts it in domestic hot water mode. Okay? The light should never blink. It should be solid red. If it's blinking, there's something wrong. That means that impeller is going start, stop, start, stop, start, stop, start, stop. This is just for domestic. That's right. And if you want to pull this valve out, you don't have to drain the whole boiler for this one. Just got to shut the cold water inlet off, open up a hot tap to bleed it off, and you can pull that right out. You have to have an 18 millimeter 6-point socket to take this out. A 12-point won't work, all right? So keep that in mind. And you can take this out with everything still all back together. You can reach back there and you can get this out of the machine, okay? So that's how that filter assembly works. You do not for this. And if you do have to drain the heat loop, it's right here. That drains the boiler down, okay? Okay? All right, you guys good over there? All right, go ahead and now, you already pulled it out, but pull this water pressure switch out of there. The little black water pressure switch. It's right here. Yep, just pull the clip, pull it out. Your water pressure switch is your low water cutoff. It's built into the machine. Now, when I say it's a low water cutoff, I will tell you that I don't find many places, if this is put into a commercial application, let's say you put it into an apartment building, I can't tell you, the inspector's not going to tell you that you still don't have to have a secondary low water cutoff in the highest point of the piping. Okay, but what I will tell you is the nice part of this low water cutoff. Once the water pressure drops below 7.25 psi, you're going to get a 118 error code and the boiler's going to shut off. So it's actually a little bit more accurate than losing water altogether before that other low water cutoff trips, okay? So keep that in mind. If you ever have one where you're getting a 118, the nice part about this boiler is when you get the package underneath, the hydronics package, it also comes with a pressure and temperature gauge. So let's say you have a 118 error code in the front, telling you only have 6 psi in the boiler, but you look at your gauge and it says you have 12 psi. That'd be because this is bad. I've taken these out of houses where I've done this, and a bunch of crud and crap comes out of there, and it's just a pin on a spring is all it is. So if it gets stuck, it's not going to read the right pressure. Okay? All right. Moving on. You have the copper pipe right here. Take the clip out of that copper pipe, the back one here, take the clip out, and remove it out of the boiler. So this one right here. Take the back one out. So pull the clip out of the top, and pull that copper pipe right out of the heat exchanger. Got it? Yep. Okay, and there's your sensor, okay? So this is one of your sensors. You have a supply sensor and a return sensor. They're identical. But the nice part is it will tell you which one is which. So if I have a 20 error code, I know it's a supply sensor. If I have a 40 error code, it's a return sensor. They also are nice enough to put a red wire on the supply and a blue wire on the return. So you know which one is which, okay? As far as the hot and the cold, all right? So that just plugs into there. Now you'll notice that some of these, you notice this one here is our old style. This one here is our new style. This is how it first originally came. We found that that was not an accurate enough reading with just that little plug on the copper. So we changed it to this, which is a flat piece of copper with a spring behind it, which gives us better reading of the temperature coming in and out of the boiler at any given point in time. Okay? All right, the other copper pipe. Did I take yours? I think I did. Take the other copper pipe off. So undo your nut on that side, undo your wires, and pull a clip out of the heat exchanger. You already had your nut undone over there, so you were a little ahead of the game. Yeah. And go ahead and unplug the wires. Now on this one, you notice a secondary limit right here. Okay, that's your high temperature limit for the internal water, for the boiler loop water. If I get a 236 degrees Fahrenheit, you're going to trip that and get a 110 error code. Remember, it's not going to trip back till it gets to about 188 degrees. So if it was really hot when it tripped and you get there and you can't reset the code, it's probably, and you do a continuity test there and it's still open because it hasn't cooled enough to close, or it's a bad switch. It could be a bad switch as well. That would give you a 110 error code on that piece of copper. Okay? All right. Go ahead and take the flat plate out of there. It's 2 Phillips head screws that hold the flat plate in. One here, 2 silver screws. You got, yeah, one there, one there. Pull the flat plate right out of it. So, take your Phillips head, remove this screw and that screw, and take the flat plate right out of it. When you pull that flat plate out and you see what it looks like on the inside, you're going to see why we have to have really good water quality when you're using a flat plate heat exchanger. That's all right. Yeah, just a little. So we're good. So there's your flat plate. It's going to be different sizes for the different boilers. If this was a 110, it'd be a little bit smaller. If it was a 205, it'd be a little bit bigger. Okay? So just different sizes. You'll notice that there's a sticker on here with an arrow pointing towards the three-way valve. You want to make sure when you put it back in, yours doesn't have it, but you have an arrow pointing up. You want to make sure you put it back in that way, because if you reverse it, you're not going to have as much hot water, because for every domestic coil plate, there's a central heating plate on each side of it. If you reverse that, you take that away, so you won't heat the water properly. So make sure when you put that back in, the arrow is pointing towards the three-way valve or pointing up. Now, yep, if you have one of these, I had a customer that had very high concentrations of chloramine in their water. Most municipalities now, most city applications will use chloramine instead of chlorine now to treat their water. Chloramine in heavy concentrations will create a white powder that looks almost like hardness. Okay? I had one customer that her house was close to where they injected it, so her levels were really high. So every year I'd pull the flat plate out when I cleaned it. I'd put another one in, I'd take that one home, I'd clean it, boil it out, put it back in my truck. So every year when I serviced her boiler, I just kept rotating the flat plates out to keep her water working properly. Okay? But again, that's why water quality can be so important with these. All right? The flat plate itself, depends on the water quality. You know, if you start seeing a reduction in your flow and pressure, then it's going to give you a pretty good idea that there's not enough water running through it at that point in time. Okay? We don't see the ton unless the water is really, really bad. You know what I mean? Iron is another thing. If you have really high deposit of iron, it gets in there, it can cause a problem too. Okay? All right. Up here at the top of your heat exchanger, right below the vent, you're going to see one black Phillips head screw. Right there. Right there. On the very top of the heat exchanger, one black Phillips head screw. Let's go ahead and pull that Phillips head screw out. So pull that Phillips head screw out of there. And then once you pull it out, pull the clip out of there as well. There's a silver clip, and pull the clip right out of there. Once you pull the clip out, you've got a red wire in the front and a blue wire in the back. Undo both those wires. Unplug them. Once you've done that, reach inside there, put your hands underneath the white condensate collector, and push up to get it out of the top of the heat exchanger. Just give it a wiggle. You should be able to push it right out of there. Yours is broken. There you go. It just went, just released. Okay? Yeah, you should be okay. You should be all right. Now take these 4 screws out and remove the heat exchanger. Now this is the part where it's nice to have a second set of hands when you do that. Yeah, so put your hands underneath there, underneath that, and push up on it. There you go. Perfect. Now remove these 4 screws and pull the heat exchanger right out of the machine. I'll find that in a minute. Now when you take those screws out, it's nice to have a second set of hands because the heat exchanger is heavy. Okay? Oh, you got to remove this too before I forget. There you go. Yeah, remove your rubber condensate line off the bottom of it too, because it'll still be attached. All right, heat exchanger's out. You've just taken every major component out of this machine in about 20 minutes. Okay? Let me have that for a second. Your heat exchanger. Oh yeah, it's got some weight to it. All right, can everybody see this right here? Okay. You have 2 sensors in the top. The one in the front is your flue stack temperature sensor. So if your stack temperature gets to 188 degrees, it's going to trip this and give you a 130 error code, right? The one in the back will give you a 131 error code. If you get a 131, that means your heat exchanger is destroyed. You need to change it. Yes. Not coming out? I think it was just hung up in this little ridge. So this one, if this one gets tripped, the one in the back here, that means the internal temperature in the heat exchanger got to 375 degrees Fahrenheit, which can melt this plastic. So that's why when you have a 131, you got to replace the entire heat exchanger. Then we have to figure out why you overheated the heat exchanger. Okay? You notice there's a gasket up here on top. If you ever get a leak right here, or down here, you're just going to replace the heat exchanger. Okay, you're not going to mess with it. You can't take this apart, reseal it. And typically, if I see that, I see it right out of the box. You know, it'll be in a couple weeks, and all of a sudden, I'm seeing a drip. Small starts as a small drip. At that point in time, you'll be changing the heat exchanger. Okay. The other thing I find is these connections sometimes. Grab me one of the copper pipes here, like this. Okay, where these go in. All right, they should be a good tight fit there. And a lot of times, if I leak, people think it's the O-ring. It's rarely O-ring, believe it or not. If I have a leak there, let's say it's been in a year, you go back to clean it, and you see this is all copper's all green because it's been leaking there. A lot of times what I actually find is that this molded round part that was molded in plastic wasn't molded right. So it doesn't seat the way it's supposed to when you put that in there. Because you think about that, that's held on by a clip. So it's got to be just perfect in order for it to seal right so the water's not coming out of it. Now granted, we're only running at 12 PSI, 13 PSI, so it's not a high pressure, but it still has to be fit in there properly. If you ever have to replace a heat exchanger, you'll notice there's a fiber barrier inside there, a white fiber barrier. If you get a new heat exchanger, it's going to be covered in a cellophane, a blue or pink cellophane. Don't worry about that. It melts off instantly when you fire the machine back off. Okay, so don't worry about the cellophane. This here, we'll talk about this. This is a bleed off. When you're purging the machine, you open this up, takes all the air out of the top of the heat exchanger. So you do it a couple times while you're purging, and you'll get all the air out of the top of the heat exchanger itself. Okay?
What's this?
Yes. That is nothing. That is, this is made by Cermeta. Cermeta makes this heat exchanger. Okay? So they make it for many different manufacturers. So other manufacturers might use it as a high vent. They might have a high vent coming out the top of the machine up here instead of this air release. We use the air release instead of the high vent. Okay?
Yeah.
Yes?
O-rings. You recommend a bunch of bumpers, grease around?
It doesn't hurt. It certainly doesn't hurt. Yeah. I will also tell you that I carry in my truck, I keep saying Harbor Freight, but for $5 at Harbor Freight, you can get 500 O-rings, metric O-rings, and they've gotten me out of a pinch before. Okay? I will also tell you, when you start talking about O-rings, let's say you go to somebody's house, this O-ring won't seat. Pull it off. Pull it off. Of course, this one doesn't want to come off. Pull the O-ring off, clean it, make sure it's clean. Okay, oh, thank you. Perfect, thank you. Pull the O-ring off, make sure it's clean, make sure it's not damaged. If it won't seat, I don't care what O-ring it is, take the O-ring, throw it in the person's freezer for 15 minutes, then pull it back out, it will seat. The cold pulls the water out of the O-ring, puts it back to shape. Can't tell you how many times I've done that, and it's worked, and the O-ring has seated back where it's supposed to be. Okay? It isn't always going to work, and that was actually, I'll give the credit for that to an Amish plumber I talked to one day. He's the one who told me that. You know, they have some interesting tricks. Matter of fact, we used to put it in Vermont. We used to have a lot of gas refrigerators in camps, right? So I had this one customer who had a gas refrigerator in his camp. He bought it brand new. It had been in for a month. Well, he hadn't been up for 2 months after we had put it in for a month. And when he got back up there, the burner head went out. So it thawed all the meat in the freezer, and all the blood ran down through all the back part of that gas refrigerator. It stunk so bad, and it was a brand new refrigerator. So I called the guy that we bought it from in Lancaster, Pennsylvania, and he said, take the door off it, clean it, take the door off it, lay it face down in the grass, cover it with a tarp, and leave it there for 2 days. Gone. 2 days later, we pulled the cover up and you could not smell anything. It was the most amazing thing I've ever seen in my life. Just the moisture from the ground took the smell out of that plastic. So even if you had a plastic bowl that had strong onion smell in it, you couldn't get it out, do the same thing. Put it in the grass, cover it, leave it overnight, pull it, and it will have no smell to it. I don't know, all this technology we have, and we can use grass to get rid of smell, right? Okay? Grass, yeah, I know, well, it makes things better maybe. I don't know if it fixes it. All right? Okay, that's all we're going to pull apart. Go ahead and put it back together. Step in. I'll help you. Don't worry. Yes.
Wilma crane. Tube in there. The burner tube comes out. It's come out also because we have a lot. I live in the country, we have a lot of LP.
Yep.
Get gummed up. Your burner tube come out and clean.
You can. You have to pull that. You just pull the. What do you need pliers for?
That one clamp.
Which one? Oh, this? Yeah, you're right. So you pull this and this out, take that off, Just take the spider barrier up, it picks up out of there. Then there's 3 bolts that hold this in place. If you have a problem with that. I've only seen in War Gas, who makes this burner, they make the burners for almost everybody. And they've been out since the late 90s with burners. And the thing about these burners is if you pull this out of here, it's a double burner. There's an inside part of the burner with round holes in it, then an air gap, then it has these holes in it. They do that because if you think about the way this runs, you would think that when it fires, the flame would want to just go up, right? You think you want to just roll up in the air. Well, because they have the double burner, it mixes it so that it goes around the whole burner itself. And I've probably only seen maybe 3 burners actually fail, and I'll show you one in the picture in a little while. That was pretty bad, you know what I mean? But they're pretty durable, they're pretty reliable. But yes, you can change it if you want to. And that's one of the things that's different as far as the 205, the burner will be about that much longer. It's a little bit longer because it's a bigger heat exchanger. So you're talking about the Ultra?
Yep.
One McLean Ultra?
Yes.
Yep. Worked on a few. Yes, we're going to go over that though, yes. Yes.
Last year,
Mm-hmm.
I have 2 GB240s in a commercial building, and they're not GB. Saying it wrong.
Yeah, the 240, I know what you're talking about, yes.
And the thermofuse.
Okay.
And 0 problem with the heat exchanger. And his name is
Steve.
Steve.
Yep. Yep.
And we went through it, and because I had taken one out of the other boiler then and put in, and we then it was fine.
So the thermofuse with the 2 blue wires on the front, that had tripped.
And it was incredibly difficult to get one because they said the same thing. If that thing's tripped, your heat exchanger's toast.
Okay.
And like the heat exchanger is intact, and it was only a 1.5 year old boiler. We did get a new part, put it in. It's ran now for a season and a half.
See, that shouldn't with the 240s and the 380s. That's not what they told you is really not true because that has no plastic on the heat exchanger.
Yeah, there's a loop.
Oh, the 380 doesn't. The 380 has the stainless steel on the whole outside.
This is the stainless all outside.
Right. So you don't have the plastic. So the reason we have that sensor in there is because it's plastic on the outside. It's a high temperature plastic, but it's still a plastic. So so that can loosen that. So for yours, we don't have. I don't think I've ever seen one go bad on a 380 or 240, but they could. They're just a sensor. You know what I mean? And you'd be able to tell if you overheat that heat exchanger. You'll be able to tell because if you run your finger across it, they should all be the same. If you go there and one's high, one's low, one's high, one's low, you know it twisted. It got so hot that it twisted. And you can also see when someone sends a heat exchanger back. Let's say we get a call, we're going to warranty the heat exchanger, but it's kind of weird circumstances. So we said we want it back. Okay, we get it back, and the stainless steel is all rainbow colored because you can tell exactly where it overheated the machine itself. That becomes then it's a whole other issue. So you would, even on the 240, you'd be able to see that when you pull the burner out of it. If the heat exchanger was still symmetrical, if it hasn't been twisted, it didn't overheat, and it was just a bad switch. Yeah. So, yeah.
I recommend flushing these things. I know we're getting a lot of household changing out in the high efficiency.
Mm-hmm.
The water system, the pipes over the years, is shitty.
It depends.
Once in a year, we have to back flush.
Yeah. Yep. Well, it depends. Now, if you took out a cast iron boiler and you still have a black iron header system in there for your supply and return, then yeah, you're gonna get flaking off of that. But if you put it into a brand new house, it's all copper or PEX.
We're getting
You know?
we're getting a lot of places where they got the copper fins and lock and bar, and they don't have air separators. So
Gotcha.
naturally, every time they have a leak or something, they're adding air and they're getting oxidation
Correct.
lines and all that.
Right.
And the water's just terrible. Even
Sure.
if you flush it clean.
Are you getting that sediment? So in other words, if you pull the water off and you put it on a table, it'll eventually settle into the bottom of the glass, so the water's clear, but you got the
And
cloud on the bottom.
We're on the heating side. We're not running the heating side. So the boilers are clogging up and having to sit all summer long.
Mhm.
Then we're having to go back and take them all apart and take them out to get them to fire up in the winter.
Huh.
So it's just we just got started putting more of these in. It's turning
Yep.
into that.
Yep.
Okay, now they have to be in them. I gotta check it.
Yeah, because water quality itself, once you've filled that loop and you've gotten a closed system, even if there's something in the water, after a month there's nothing left in the water anyway. After you've heated and cooled it, unless you're adding water to it, like oxygen, like you said,
We're getting a lot of that because we have those leaks everywhere. we're doing apartment buildings, we're throwing these things in.
Yep.
That's where we're running in because they're having to bleed every room because they won't buy the air separators, they won't buy the dirt sediment separators.
Gotcha. Yeah.
It's like,
So yeah, in that instance, yes, that's what you'd have to do. You'd have to just go through and purge it once a year when you're there to service it. Get as much of the crud out of there as you possibly can. You know, but the other problem we always have is if you have a house, how many houses do you go to? I don't know about here, but in Vermont where I live, a lot of houses had the old cast iron radiators, and people want to keep them. Well, there's so much sludge in those. Unless you can take them all out individually and really flush them well, how do you get the stuff out of there? So what we recommend is, at the very least, put a Y strainer into the return side so it can catch heavy stuff as it goes by. But the best thing now is they have the magnetic filters. You put that in there, it's going to grab everything off there as it goes by, and it's not going to get into the pump or the heat exchanger and make problems over time. You know, I live in a little town called Roxbury. It's probably
Southwest.
12 miles from Montpelier, the capital, which is right in the center of the state.
I can't remember the town. We stayed on Lake Champlain 2 years ago.
Yep.
And up to Burlington. And
Yep.
just all around.
I was just at the lake last weekend duck hunting. So
Yeah. Good times. Beautiful.
recommend application on white vinegar.
doesn't hurt. Yeah, some guys will use Fernox or Sentinel too. You know, Fernox and Sentinel are both, they make a cleaner, they make a stabilizer. You sell a cleaner or stabilizer? You sell any kind of, rub any kind of cleaner or stabilizer like Fernox or Sentinel? You go Sentinel. There you go. Okay, so Sentinel does the same thing. So if you wanted to put the, you know, you can inject that stuff in there as a cleaner, and then purge it, and then put the stabilizer in there, and that'll help as well. You know,
I do domestic water every year. And
domestic hot water, again, it all depends on the water itself going to it. I've never pulled the flat plate off of mine. Never had to. My water's really good, you know. So it's all based on water quality. So, but what you could do is, if you're worried about that, where the cold water goes into the bottom of the boiler, put a boiler drain and an isolation valve there. And on the hot water side the same way, and that way you can put it through there if you have to. Use a pump and pump it through there. Yep. You got it. Yep. It is. Sure. Yep.
And also in the house twice a year.
That's right. That's right.
You didn't even do it.
Yeah. We cover cleaning and servicing on these too. Okay, questions? Yep, that's your front one. Then your blue one is for the back. Yeah, you got that one. Yeah. Oh.
We're talking about like X400,
Yes.
X400
Yes.
cleaner,
Yep.
X100 inhibitor.
You got it.
Okay.
Yep.
Yeah, that's something we could work with 2J on getting.
That's right.
You guys got little kits made up where
So how exactly does that gas valve determine what gas is going through?
That's a great question. When these are fired at the factory, okay, there's 3 parameters way up in the 800 range of parameters. Because this uses what they call Lambda Pro technology. So does the Vito Dens from Viessmann. They use the Lambda Pro technology. And the only other one that does that right now in the U.S. is the Phantom from Velocity. They use a type of that system too. So what happens is, when the machine fires, it's looking at 3 different parameters, okay? But it's looking at everything. It looks at stack temperature, looks at supply and turn water temperature, looks at everything when it's firing the first time. And it tries to get to that number, okay? Now, when you go to convert it, when you commission it, because it comes out of the box for natural gas, when you commission it and it fires, it sees what the stack temperature is, it sees what the flame signal is, it sees all that stuff, and determines the specific gravity of the gas to figure out if it's natural gas or LP, and changes it accordingly. Yep.
We can do that, but we can't do that on the gas furnace.
Yeah, well, gas furnace is so much different because gas furnaces are still ribbon burners. You know what I mean? Atmospheric ribbon burners with a power emitter on them, where these being a negative, and I don't know if there's any, and there's not even any warm air furnaces that have a negative gas valve in them right now. You know, so when you think about, because it's multiple burners. You know, so when you think about that, it's hard to do that. You have to, that orifice is a certain amount of BTUs to that particular warm air furnace, so you got to pull the burners out, change the orifices, put a spring, sometimes a spring in the gas valve, whatever you have to do to convert it. So it makes it a little more difficult. It is, yes, it is. Yeah, well, there's been talk about that, you know, but it's hard because then you might have all these boilers that were propane that sit on the shelf for long periods of time. You know, whereas if they come out for natural gas, then you can convert them on on site. It makes it easy. But there has been units in the past. A lot of the Renai units are fuel specific. You know, if you buy like a Renai space heater, those are fuel specific. You order them natural gas or LP. Now you can convert them if you want to, but you order them the gas you want.
Do you guys come out with like an oil version of this too?
We don't have there's no wall hung oil stuff. I mean, we have cast iron stuff, but nothing that's stainless steel at this point in time. You know, condensing for oil is tough because if you don't have low sulfur oil, when you condense, you make hydrochloric acid, which eats through any heat exchanger you put in there. So that's been the issue with condensing oil boilers. They make them, people make them, you know, and as long as the oil is low in sulfur, it's okay. It works all right. So.
Remember how to get in once you raise the temperature when the boiler kicks on. I've been flipping there and I can't come up. I can't find it in here. I don't know.
We sneak by here, see how everybody's doing here.
Oh, excuse me.
How's it going? Any questions? You good? Okay.
The boiler's kicking on 35. She wants to get on before you.
Excuse me. How we doing over here? Any questions?
Trying to figure out where the condensate line is. Really?
This one doesn't go anywhere. It just hangs there. It's usually a little thing. Oh, this one? It used to have a thing right here. It's gone. It would go out through there like that. Okay. It's just to vent the water. That's the air pressure switch. So it's a flue blockage switch. It's a positive pressure switch. So if you block the temp, if you block the flue, creates a back pressure, opens it. They put a second hose in there so that the changes in pressures inside the box won't affect the diaphragm from going up and down. Yep. Mm-hmm. How we doing, guys? We doing okay? Any questions?
I'm drawing a blank. I don't think I could.
So if you're in here and you're looking for something, you can always ask them.
We got one clip where
That goes in the water pressure switch. Yep, that goes in the water pressure switch.
Okay, so all these coils, is that all stainless steel?
Yes. Yep.
So every unit's got the stainless steel in them?
Just like that.
That's what I was
Yeah, and what they do is they come in sections like this.
Yeah.
Then they're connected based on how big the heat exchanger is.
I'll be damned.
Okay.
So something like that, say it starts plugging up, are you able to run like white vinegar?
You can. Well, I'm going to tell you that because of when Cementa designed this, and they started making these, I don't want to swear to anybody, but they started making these with remember the Munchkin boiler? You remember the Munchkin? Okay, the Munchkin had this style of a heat exchanger. It was actually called by a company called Giannoni, and Giannoni sold to Cementa. So the oval shape of that
might be hard.
Actually impedes the buildup. The velocity, the way it goes through that oval shape, they found it impedes the buildup of stuff inside there. So
because it speeds it up going through.
Correct. Because it creates velocity, which helps to keep it. So I have never, even the one I have in my house, I've never done anything to the water side.
I don't think that's not going to clog up.
Yeah, that's a pretty wide.
I was going to say,
Correct.
Yeah.
Yeah.
The holes are a lot smaller.
Yeah. The only problem we ever had with this was early on in 2013 and 2014, we had a bunch of heat exchangers, I say a bunch, probably 25 in a couple years, where we're getting this weird noise, harmonic noise, where it would be so loud that it would reverberate through all the copper in the entire house.
Oh, shit.
So the first one I went to was in Pennsylvania, and I'm like, I'm thinking it's got to be hydronic related. You know what I mean? So I get there, it's making the noise, but if I start shutting ball valves to slow my flow down, the noise doesn't change. Well, if the noise doesn't change, it's not hydronic. You know, if I start slowing the flow down, the noise should change. It should change. So now I know it's combustion related, right? Couldn't figure out what was causing it. We sent the guy a new heat exchanger. He changed it. He sent it back to us. We cut it open. When we cut it open, we found a material, well, it was like stone, that had connected 4 or 5 coils together.
Oh, damn.
Okay, and when it connected them together, when the boiler got to about 165 degrees or about 75% of its firing rate, it couldn't vibrate, so it would knock.
Oh, damn.
Through the whole house, right? Well, after we had the 4th and 5th one, we sent them back to Cementa in Europe. And they came back to us within like a month and said it was their deal. The tolerances on see how the coils, when they're made, they have a certain tolerance there. they found that in one batch the coil tolerances were too tight, so the air couldn't go through properly, which would make it condense.
Oh, okay.
The condensation would ionize, turn to a mineral, and attach the four coils together.
Yep, naturally will.
So yeah, so every once in a while a guy could take a credit card maybe and get lucky and knock it off, and the noise would go away, but it would come back.
Oh, yeah.
You know, so the only fix was to replace the heat exchanger.
Awesome.
Yeah.
Yeah, I do a lot of work over 9 units.
Yep.
It's so much better. So much.
The Renai boilers? Yeah.
Well, we've only done maybe 2 or 3 of the Tommy boilers, but other than that, some plumber I do the best.
Yep. Yep.
You can't work on them.
Yeah.
And there's no room in them.
Yeah. Well, the same thing with the Navian. They're good. They're not. You know, guys will always kind of push me into a corner and say, "What do you think about this boiler? What do you think about that boiler?" If you put it in right and you maintain it, it's going to run.
Yeah.
I don't care what the name is in the front. I mean, you know, we're moving water in a circle. That's all we're doing. We're not curing cancer. Okay. It's just how you fix it, how you maintain it. That's right. Yep.
This one will do both at basically the same time. And you can do radiators, baseboard, radiant floor, air handler with a hot water coil in it.
Yeah, basically you're heating the water in here.
Hey Bob, what would be more efficient, going through a radiator? What would be more efficient, going through a radiator with one of these or going through an air handler?
Efficiency is all about water temperature.
Yeah.
So an air handler, you could run your water temperature about 140 and still get the BTUs you need out of it. Okay. So keep in mind that if you're going to condense a boiler, the flue gases have to drop below the dew point, which is 134 degrees.
Okay.
So if the water temperature coming back is below 134 degrees, you're going to condense. It's going to condense. Okay. If your water temperature starts to go above that, as you keep climbing above that, on your way to 180, you're going to get less and less condensing because you're expanding that dew point. So if you put this in somebody's house and they have in-floor radiant, and you can run that water at 112 degrees to the slab, which you could, you're going to get 98% efficiency almost all the time. It's going to condense all the time. But if you put that in a high temperature home, which has radiators or fin tube baseboard or that kind of thing, and you're running at 176, you're still going to save fuel because of the modulating gas valve.
Right.
You know, because it only burns what it needs to. So you're going to save fuel that way, but you're not going to condense as much.
Okay.
That's why it was sad. 2 years ago, we used to sell a non-condensing wall hung boiler too, called the Cub. And it was a great little boiler because, you know, a lot of people don't need a fully condensing boiler if they have high temperature baseboard because you're not condensing anyway. Well, 2 years ago, the federal government changed the efficiency standards of those boilers and put them in an area that we couldn't meet. And that manufacturer is not going to try to change the world for a non-condensing boiler, so they just stopped selling them.
I'll be damned.
Yeah, you know, so it's.
I heard they passed a thing on gas furnaces. They're doing away with them too. They're going to make the news.
They're gonna keep pushing until they can get everybody to try to go electric. That's what they're aiming toward. We're finding right now. Listen, probably 65% of our business at ECR is still cast iron boilers. 65% of our business. In 2025, they're going to change the efficiency standards for water, gas, and water steam. They're not going to touch oil, gas, and oil steam, but they're going to touch. They're going to keep the oil is not going to change. And when they change those efficiency standards, if they go up 3, 4, 5%, you're not going to be able to meet it. Right. You know, we're already seeing, you know, from a wall hung boiler standpoint, with the advent of, you know, that big one goes here. This one that one goes there. Yep, that one goes there. You know, since heat pumps are becoming so popular, you know, there's 35 different wall hung boiler manufacturers in the U.S. 35. Last year in the U.S., we sold 250,000 wall hung boilers between 35 different manufacturers. So if you know, so you think about that market share was small anyway, and now you start pushing everybody towards heat pumps, and which is taking another bite out of that market share. You know what I mean? So it's
amazing right now.
The reason we do that is so that you can see that if you had to change it, it's not that big of a deal to change it. And the good part about the error codes is most everything is specific to that one part of the boiler. So the thing to remember on almost anybody's boilers now, if it's not that component, then it's the board. Those are the two parts of that puzzle you have to remember. Okay, if something's not reading right, but you do an ohms test in that and it tests out okay, then it's the board not reading it back from you. Okay? All right. Okay, just a quick, I told you about the spark plug tester. Okay? This is going to give you an idea. I actually have a little video of it. Remove the sparker off the heat exchanger. Attach the spark plug tester. Then attach the rod to the sparker itself. Fire the unit. shows you the spark is actually going. All right, so that little simple tool, but it's really hard to see the spark inside there. To look through that observation glass and see if you're having the right amount of spark. The other nice part about that is, let's say that you didn't know if you were rectifying flame or not. Well, the nice part about that is, put the tester on there. Okay, if the burner shuts off the same time the spark does, you know you're not rectifying flame, right? Because the burner should light, the spark should shut off, the burner should stay going. If you're shutting off at the same time, you know you're not rectifying flame at that point in time before you do a microamp test. Okay? Real quick about this service key. Every PCB board has a service key on it. Now what the service key does is if you have to change a board on one of these, you change the board, put the new board on, put the service key off the old board and the new board, remembers everything. Remembers any parameters ever changed, remembers your fuel type, remembers everything. It makes it very, very easy if you have to change a board. You haven't got to go back in and change any parameters. It's all done for you through the service key itself. Okay?
So are all the boards the same in all the units?
They are.
Okay.
Identical. From a 75 to a 205, it's the same exact board. Yep.
Does the new board come with the service key or you just take
Does
it?
not. Well, let me rephrase that. Right now, the Dunkirk, when you buy it's called a kit. You can get just the board, you can get a kit. The kit comes with the key in the back, in the box. Yeah. Covered all that. Covered all that. Pass there. Venting. Okay. To me, most important part of the install is right here. And I say that because as contractors, this is the only thing we do on the boiler where we could kill somebody. That's the truth. Okay? Every boiler makes carbon monoxide. I don't care what boiler it is, it's going to make some levels of ppms. Ours is the same thing. On low fire, you're going to have almost no ppms, and high fire, you get 75 ppms. All right, so making sure our vent is proper is how we're going to make sure that our flue gases are going outside the house and not being inside the home. Okay? We're pretty flexible with ours. We can use a coax pipe, we can use CPVC, we can use PVC, and we can use polypropylene. Now, PVC is all based on your local codes. In Massachusetts, you can't use anything but polypropylene. The entire state, doesn't matter what the manufacturer says, you gotta use polypropylene. California is the same way. New Hampshire's the same way. And I'm assuming that eventually Vermont will be the same way as well. Now, polypropylene is great because polypropylene has a much higher melt temperature than PVC does. Okay, keep in mind that regular Schedule 40 PVC has a melt temperature of about 140 degrees. But the temperature is not what makes PVC punky. If you ever get to somebody's house and they have PVC in their vent and it's brown and it's punky, it's not because of the heat. It's because of NOx, nitrous oxide. Okay, everything that runs off gas, that burns gas, creates NOx in the flue gases. The higher level of NOx you have, the more that nitrous oxide can break down the polymer in that PVC. And that's what makes it punky. And that's what makes it turn brown, not the heat. Because think about it, when this thing is running, my flue stack temperature is rarely above 135, 140 degrees. Because you have a fan that's pushing the flue gases up through there. So you're getting some residual cooling of the fan blowing it up through the heat exchanger anyway. And then when it gets out the vent, it's gonna cool down even more. So it's all about NOx. Even in our machine, probably 75% of our flue gases is nitrous oxide. The rest is CO2, O2, and CO. Okay? So keep that in mind. As long as your codes permit it, PVC is fine. CPVC is better, has a higher polymer content, so it's not going to get the NOx is not going to affect it as much. But the polypro will not be affected by NOx at all. If you go the coax pipe, that's polypro on the inside and cast galvanized on the outside. If you want to go coax, okay. Again, you go two-pipe system. These are different kits that you'd have to have for a two-pipe. This adapter could also go on top. If you use this style here, or this style here, you have to take this cap off and put the fitting on there and screw it back on. I like that better because if I do this, I have to take my makeup air from this side of the boiler. If I do that, I can move that any way I want. It makes it more flexible as far as when I'm doing a two-pipe system, okay? That bottom kit would be for CPVC or PVC. The one above that would be for polypro. So this would adapt you from 3-inch polypro to 3-inch PVC or CPVC, okay?
Does that have to be fitted in 3-inch?
No, it can be fitted in 2-inch as well. But in 2-inch, it has to be poly. You can't run 2-inch PVC. That's the only stipulation when you go 2-inch. So there you go, 2-inch poly. Your exhaust can be 85 feet. Your intake can be 85 feet for a combined length of 170.
NH90, long-term 90, that's 5 feet?
There you go. You're getting a little ahead of me. Stealing my thunder. It's okay. But yes, coax is pretty much standard. 32 feet is as far as you can go with coax. Then you got to take every 90 and every 45 off your total bend length as well. I would tell you that most of the jobs I go on, if it's just up and out, so boy, they hang the board on the wall, they take 190, they take a horizontal termination of coax and just push it out through the wall. Easiest way to do it, okay? The shorter your vent run, the better the machine's gonna run. I don't care whose machine you put in. The shorter the vent run, the better they run, okay? So keep that as short as you can. When I look at putting a boiler in somebody's house, even a change out, to me, I can move water lines, I can move gas lines. I'm gonna put that vent where it's the handiest for me to put the vent out and make it the shortest run that I possibly can. Instead of keeping it where all the piping is and then run 60 feet of PVC to get outside the building, okay? So there's your distances you can have. These are for that sizes, 75 through 150. And if I go 165 through 205, the 2-inch doesn't change, the 3-inch doesn't change, and the coax doesn't change, but the PVC and CPVC, I'm sorry, the 3-inch changes a little bit as far as distance goes, how far you can go, all right? And then these are the 90s and the 45s that you're gonna take off for the smaller models. And again, this is all in the manual anyway, okay? And then the same thing for the 165 and the 205, giving you the numbers you need for that, okay? If you use a coax and you put a 90 on the top of the unit, that 90 is free. But if you cut a 3-inch extension and put a 90 in it, you gotta count that 90. One of those weird little rules that are out there. But if you have it on the top of the unit, you don't have to take it off your total bend length, okay? Just showing you the splitters again. Just showing you that again, how it would look differently than this, okay? Yeah, it's a much cleaner, I like that left-hand one. It's just a much cleaner install. You're going 2 pipe.
So if you were going to pull the makeup air from the basement or whatever, how big is that be?
Great question, okay? You're gonna take your length times your width times your height of the room. That's gonna tell you how many cubic feet of air you have in the room. Take the max BTUs and divide it by 20. As long as your second number is, the first number is bigger than your second number, you can take it from the basement, okay? I like keeping it direct vent because it's the safest appliance at that point in time. If I have my makeup air on the outside and exhaust on the outside, then that box is sealed, and no matter what's going on inside that box, it's never going to affect the house. I know where I live in Vermont, the houses now are so tight, you couldn't take the makeup air from the house anymore. It can change the pressures in the home, start making mold and all this other kind of stuff. You know what I mean? It seems crazy to build a house so tight, they'd have to put an air exchange unit in it, a heating ventilator recovery unit in it, because you can't, it can make mold because the house is so tight. So I like going 2-pipe. We're very versatile with 2-pipe. We can go different atmospheres. Hasn't got to go on the same side of the house. We do, so, different atmospheres don't bother, okay? Where's my other picture?
You didn't have to take that plate off.
These are a big no-no.
And then.
Don't use these with our boiler, okay?
You're not locked into that spot.
You get too much cross-contamination with these flat terminations, these concentric terminations, okay? And I know that they sell them, different manufacturers sell them. Remember, our product is certified to be used with what we call Modulating is what we sell for our Polypro and our coax, but you can use Duravent, you can use Centrotherm. They're all approved with our product. So you haven't got to, so you can use anybody's coax or anybody's Polypro. This is what you get more for a warm air furnace. They use these. Some of the Well McLean boilers use these kind of terminations, okay? Just don't use these. You're gonna get, we've tested them thoroughly. We get a ton of cross-contamination with them, okay? Something like that is fine. You can snorkel it. As long as you have your minimum of 12 inches across there, you're okay as far as your intake and your exhaust. What you don't want to do is you never want to leave that exhaust pipe just sticking straight out where the wind can blow right back in the inside of it. Because what you'll see, especially on our 165s or our 205s, is you'll see a big rust stain on the side of the inside of the box. Because what actually happens is when the wind blows down through, it actually picks up some of the residual condensate inside there, blows it down through the fan and out that venturi. And it's acidic, so it rusts the side of the jacket. So you always want to have some kind of a fitting on your exhaust on the outside. It's a 45, a T if you want a T, that's fine, or a 90 pointing down. You don't want it so it can blow straight into the machine itself. Okay? Coax, like I said, you can go through the roof. They have 90s, 45s, and terminations. If you're using this piece here, the whole termination is free. So that whole piece is not counting the total vent length, right? It's just from the boiler to to the bottom of that. And this is a basic installation, so 190 and the horizontal termination out. Like all venting, you want it pitched back towards the boiler, 1/4 inch per foot, back towards the boiler. You don't want any condensate coming out the end of that. I go to houses where, you know, there's a big chunk of ice on here, you know it's not pitched right. If that chunk of ice gets too big, it blocks off the pressure intake and now the boiler won't run, okay? So keep your pitch back to the boiler, support it properly, and you won't have any problems. All the fittings for coax come with screws in the box. They also come with like a water-soluble grease on each fitting to grease up the O-rings and whatnot. But you want to make sure you screw to the top of the unit and you screw the extension pieces together when you're using a coax pipe. If you're going to cut these extension pieces, you want to take the inside pipe out of the extension, measure them separate, cut them separate. Then you got to deburr the cast galvanized, deburr the polypropylene, and chamfer it a little bit before you slide it back there so you don't roll any O-rings, okay? What I see a lot, I had a guy call me from Brooklyn, New York. He said, I've got a 150. He said, if I have a front cover off, it runs just fine. If I put the front cover on, it won't run at all. So you have cross-contamination. He goes, no, I don't. Well, yeah, you do. If I run the front cover off, but with it on, you have cross-contamination. He said, well, can I leave the front cover off? If you want to kill everybody in the apartment, go ahead. You know, because at that point in time, you're bringing CO back into the house. You know, I don't know about out here in Ohio where you guys are, but in Vermont, we typically still have 6 or 7 carbon monoxide deaths a year in our state. And last year was a particularly bad year because our biggest college in Vermont, University of Vermont, they had off-campus housing that had 12 students living in it. Contractor went in to clean the oil boiler, never put the vent back on. And that night, 6 out of the 9 kids were dead the next morning. And the others were sent to the hospital for carbon monoxide poisoning. So obviously that contractor's in jail, and he's never coming out. Okay, so that's when I talk about venting and that kind of thing, that's the only part that I really would always spend a lot of time on to make sure it was right. Because I never want to be in that position where I had to try to answer questions about why this wasn't right and this happened to somebody. Okay, so liability-wise, you just want to make sure that the vent is the way it's supposed to be, and you won't have any problems. You don't need to talk about that. And the carbon monoxide detectors. You know, it's cold most every place you go, it's cold, but how many houses do I go into that have no carbon monoxide detectors now? It doesn't make any sense. They're not that expensive anymore. You know, and they're more accurate. You know, when First Alert first came out with their first detector, all it was a piece of litmus paper with a light would pass through it. And if you got CO in the house, it would darken up the paper so the light couldn't pass through it, and that's how it sounded off. That was the first CO detectors they ever came out with. Now they actually test the air and they know how many parts per million you have going through the house. So, questions about venting. If you're putting in other people's boilers, it doesn't change that much. The clearances don't change. Most of the elbows are the same. All that stuff is the same. You know, so just you know, pay close attention to that. You won't have any problems. Gas supply. You need at least a manometer. Okay, if you called me with a 133 error code, what's the first question I'm going to ask you?
What's a 133 error code?
No, I'm going to ask you, what's your gas pressure? And if you tell me it's good, I immediately lose service on my phone and I can't get connected back again. Okay, I've got to know at least a number. Okay, so whether you have an old YouTube manometer, I don't care. A digital manometer, that's fine too. So I can know what your static pressure is and your operating pressure is. Those two things tell me a lot. If the machine won't light, and I don't know if my gas valve is opening, well, if I put my manometer on the gas valve, and I've got natural gas and it's 7 inches static, and the machine fires and that doesn't change, my gas valve's not opening, right? Pretty much tells me that.
Is it adjustable?
The gas valve? It is, but not on the gas valve. We'll talk about that in a little bit further. You can jump ahead of me. You can be quiet. Okay. So we got to know at least that, okay? Test port is right there in the gas valve. Just take a small flathead screwdriver, open it up, slide your manometer on it. That's going to tell you what your static and operating pressures are for that machine, okay? CSST pipe. You guys use any of that stuff? Track pipe, ward flex, gas pipe, use a lot of that. Just be careful of that. If you've been to the training class and you understand how to size it, based on a little chart they give you, because if you're running a longer distance, you might need more than 3/4 inch. You might have to up it to 1 inch when you use CSST pipe because the corrugation in it creates resistance. Okay, I have no problem with it except for that fact. I had a call in Pennsylvania. I had to go on. The guy called me, brand new install. I was on the phone with him for 2 hours. I could not get this machine to light, no matter what I did. I asked him 4 times, what is your static pressure? It was propane. He says, I got 11 inches static. I've got 10 inches when it tries to fire. I said, okay. Next morning I got up, drove 8.5 hours down to Pennsylvania from my house, walked into the job site, put my manometer on it, had 11 inches static and 4 inches operating. He had 197 feet of 3/4 track pipe going from his second stage regulator to the unit. And that's why you were getting that giant drop. Now, he was lucky it was propane. So he was able to get a 2-pound regulator in the outside of the building, put a maxi troll by the boiler, and took care of the whole problem. And the machine ran the way it's supposed to. So with these machines, it's not like older pieces of equipment with atmospheric burners and shutters, air shutters, and that kind of thing. This is a 1-to-1 combustion ratio. And everybody's the same way. Whether it's us, or Beesman, or NTI, or Bosch, Wellmaclean, everybody burns at a 1-to-1 combustion ratio. Whereas if I have an old gas-fired furnace, you might be at 27-to-1 combustion ratio, okay? So because you have that 1-to-1, and because my fan changes speeds in modulation, I have to have the volume there to feed it. I get this all the time. There you go, right there. Now the contractor did what he was supposed to do. He piped out 3/4 black iron from the unit right to the outside. Gas company came in, put a second twin-stage drain in a tank with a small piece of 5/8 copper. Well, if you drop below 8 inches of water column pressure on propane, the machine's not going to run. If you drop below 3.5 inches of water column pressure on natural gas, the machine's not going to run. Can't run below those two numbers. Well, we got there, had 11 inches static, it was like 3.9 inches operating. All because of that little piece of 5/8 copper. Now, when I told the tech that, he reached in his back pocket and he pulled out his little Regal regulator book. And he says, that 5/8 copper will carry 250,000 BTUs. And he's absolutely right, it will. I don't care. I don't care about BTUs, but I care about volume of gas. When that's running on low fire and that fan's running at 1100 RPMs, and all of a sudden it calls for high fire and that fan spools up to 6,000 RPMs and starts sucking the gas to that gas valve, if you haven't got the volume, you can't sustain the flow. Okay? So as long as your volume is right, your line size is right, you're not going to have a problem. Okay? Natural gas or LP. Now, you got, I know in a lot of your, what we call maybe the mid-Atlantic section of the country, I know Pennsylvania, a lot of parts of Pennsylvania, people have their own natural gas wells. Do you have any of that in here, in Ohio at all?
Eastern Ohio.
Eastern Ohio? Okay. You gotta be very careful with those. Okay, because unless they spend the money to put scrubbers in and water elimination and all that on these natural gas wells, they won't run. These machines won't run on those wells. Okay, so keep that in mind.
The old shit would run.
Okay, the old stuff would run on it, that's right. Well, you think about it, there's parts of Philadelphia we can't put our boiler in because it's low pressure in the street and the gas company doesn't even guarantee 3.5 inches of water column pressure. So there's a lot of machines you can't put in there because you just can't have the gas pressure just to keep the flame burning the way it's supposed to. All right, we'll keep going. So these are the manifolds I talked about that come in the box with each boiler. Obviously, if you get a floor mount, it's already installed on a boiler and it comes out each side of the bottom of the jacket. If you have a floor mount one, okay? Comes with a relief valve in the box and comes with a temperature and pressure gauge as well. Just screw them on there, okay? If you don't want to use that, you can cut them and go to your own closest space tees, your own hydronic separator if you want to. If you don't want to use the manifold we give you. Some guys don't want to use the manifold because now I have to go supply out this side, return out this side. So if I want to have them both on the same side, I got to elbow it back around. So if you want to save a little time that way, you can just cut those off and pipe it yourself to your own closest space tees, if that's what you want to do. Okay. These are just basic piping diagrams. I don't think we need to go over those. Pretty cut and dry. Wiring and power. Now, we would love to have an isolated circuit on its own breaker. We rarely get an isolated circuit on its own breaker, okay? Just make sure if you don't, that you don't have anything like this with a bunch of stuff plugged into one outlet, okay? That can cause a problem. These are pretty forgiving. When I go to a job site, the first thing I do is I take this little piece out of my tool bag and I plug it into the outlet. That tells me instantly if my ground is correct and if my polarity is correct. Because if your ground isn't right and your polarity isn't right, you're not going to rectify flame on anybody's boiler, okay? So that little tool, plug it into the wall, takes care of that in a hurry. If you want to use a surge protector, and remember these are dual fuse protected. So on these machines, I have a cover on it, I have two fuses. They come in little holders. One in the hot, one in the neutral. Okay, so it's going to take care of most any kind of surge you get. It's going to pop the fuses before it gets to the boards, okay? Stay away from these. And if you talk to anybody's boiler manufacturer, you don't care who it is, they're going to tell you do not use the power strips. The PID technology that are in all these boilers do not like these power strips. I don't know why, but you're going to have all kinds of ghost and weird error codes if you use a power strip like that. So plug it into one outlet. If you have a double outlet and you want to have your condensate pump in the other one, I don't have a problem with that. Okay, but just don't have a bunch of stuff plugged in there. Okay. They are in series. They're in parallel. The fuses. One for the hot, one for the neutral. Okay. Backup generators, not a problem. I have no problem with generators. I have a generator at my house, runs my boiler, no problem, and I have no power. Now I have a 7500 kW wheeled out of my garage. I start it. I got a Gentrend box in my basement, so I plug it in, flip 4 breakers, and I'm using the power in my house. We don't have any problems with ones that have automatic start generators, no issues. The big thing is hertz. If you got an old generator and you can't maintain 60 hertz, you're going to have 384 error codes in that machine, which is low voltage. Okay, the hertz has to stay high. If you have somebody with an old photovoltaic system, an old solar system, sometimes these old inverters on these old solar systems, the sine waves won't match. So you gotta be careful of that. But other than that, generators are not a problem with these machines. Okay? They'll run down to about 87 volts and the machine will still run. Once you drop below 87 volts, it's gonna throw a 384 error code and it's not gonna run anymore for low voltage. I've seen some crazy stuff. I have one of these Eagle testers. We have one at our office in Utica too. If you ever had a unit that we had talked to you and we had done everything that we could and we think it's a power issue, we'd send that to you. You'd plug it into the outlet. You'd plug the unit into that. It will take a reading every 30 seconds for up to 7 days on the voltage coming through there and give me a whole graph. I had a lady in Maine that I did that to. She was getting 384 error codes. We put the tester on there. She didn't have any voltage above 89 volts and sometimes it was 30 volts. Now, what can cause the low voltage in a house? Well, a few things. Obviously, bad transformer on the pole can cause that. All right? Any loose neutral anywhere in the system. And I don't know about here in Ohio, but in Vermont now, they use aluminum wire from the transformer to the meter bar, okay, to your meter socket. Well, aluminum will expand and contract in the hot and the cold. And in the cold, if it contracts enough on the neutral side, it makes it a little bit loose. You can get voltage reductions inside the whole house, okay? So how many times have you been to a job site where they're building 7 houses in this development, right? And you're there working and a contractor runs a chop saw and all the lights go dim. If the lights are going dim, there's a problem, okay? You have an issue with power there at that point in time. Because a lot of times they'll build 2 houses, put a transformer in the pole, then build 4 more and not put another transformer on. So they're all trying to run off that one transformer, which can cause problems as well, okay? You have your secondary wiring box. Go a little bit further. The bottom is your high temperature, so there's your fuses right there, okay? Then you have your secondary terminal, which is these things. So you have a 0 to 10 volt signal you can have on 9 and 10. This is your 24 volts end switch is 6 and 7. Outdoor reset is 4 and 5. And the open therm is not used anymore. We used to have this really nice Wi-Fi thermostat. But when BDR Thermea sold the company to Granby out of Canada a couple years ago, that software they had for that thermostat was proprietary to BDR Thermea. So you couldn't get the app anymore. I still have it in my house. Because I already had it in my house, I still have the app. And it's great for me. I travel a lot. So if my boiler locks out at my house, I'm going to know it before my wife even gets cold. Now, it's not going to solve the problem because I'm not there. But I'm going to know that boiler's down because it'll actually send me an alert, tell me there's an error code on my boiler. And that's where that used to wire was 1 and 2. But unfortunately, we have probably 2,000 of those thermostats sitting in Utica and no way to hook them up or sell them to anybody. So, outdoor reset. You guys use a lot of outdoor resets in your boilers? Okay. They work fine. Ours is the same way. So if it doesn't come in the box, you have to order it separately. Once you wire it to 4 and 5, now when you press the plus and minus buttons, it doesn't change temperature anymore. It changes your curve. So instead of reading temperature, it would read 90, 80, 70, 60, 50, 40, 30, 20, or 10. And you'd set your curve accordingly based on what you have for water temperature and what your outside temperature is going to be. Okay? I can't tell you how many houses I go to where they put the outdoor reset on it because they had to have an outdoor reset to get the rebate from the state. But the wires just coiled inside the boiler. It's not even hooked to the machine. Okay? They work fine. They're going to give you better efficiency if you have a radiant floor heat system. Something low temperature is going to be better than high temperature, but it's going to give you a little bit better efficiencies in the shoulder months of the year in spring and fall. Okay.
We will cover commissioning and setup of your boiler. First, remove the cover to gain access to the control inside. It's a good idea to check the circulator pump to be sure it is spinning freely. Remove the front cap, give the impeller a manual turn. Then replace the front cap. Make sure the unit is filled with water and all the piping and venting has been completed. Your unit is now ready to be commissioned. Plug in the unit and the boiler will turn on. On initial power up, the display will flash all icons, followed by the firmware version of the boiler. Then 000 will be displayed. Press and hold down the IP button and the Radiator Plus buttons at the same time for 6 seconds. On will be displayed, followed by 312. The unit is now in the deaeration function. In the deaeration function, the pump will run at different speeds and the three-way valve will open and close. This is where you will use the manual air release valve on top of the heat exchanger to make sure there is water coming out and that there is no air left in the top of the heat exchanger. The deaeration runs for about 10 minutes. Once completed, the boiler will fire up. Notice the flame icon showing the burner is lit. This begins the gas identification process. You should open a tub filler or several taps. This will cycle through 000, internal temperature of the boiler, and percentage of firing rate. The unit will run for 6 to 7 minutes, adjusting firing rates and identifying gas type. The gas type will then appear on the screen. If it is natural gas, NG will be displayed, and no further action is required for the gas identification process. If LP is displayed, confirm it by pressing and holding the IP button down for 6 seconds. The main screen will be displayed. This completes the gas identification process. The next step to complete the commissioning of the boiler is the auto calibration, which we cover in another video. If you have any other questions, please refer to your installation and user manual that comes in the box.
So when I tell you that it converts itself, that's how it converts itself. These are fired off at the factory on a test stand on natural gas. And then when you fire them off in the field, now, who was it who asked me about how it does that? Was it you? It was you, yeah. Just a quick, this is what they call Lambda Pro technology. Okay, we have it. The Vitodens from Wiesmann uses it. And the Velocity Phantom uses the same kind of technology. I think at this point in time, we're the only three that do that. Now, it's not a magic wand, okay? We don't have CO2 trim on this machine. Some boilers, some big commercial boilers have CO2 trim where they're actually measuring CO2 all the time and adjusting the gas valve and the fan to keep it combusting right all the time. That's only in big commercial stuff. What we do is we have 3 parameters way up in the 800 range of parameters. 3 numbers, 800, 801, 802. 800 is low fire, 801 is ignition, 802 is high fire. Those numbers are set on the test stand. So every time a machine runs, it's looking for those particular numbers, all right? Now, when you fire it off to get the gas identification process, the machine looks at everything. It looks at stack temperature, looks at gas valve placement, RPMs of the fan, supply and return water temperatures, ionization level of the flame rod. It looks at all that stuff to try to get to that number. So it can determine by those numbers whether we're using propane gas or natural gas. And that's how it converts itself, okay? So now there are times I've had units that guys have called me and it wouldn't finish the process. Something was wrong, it wouldn't finish the process. If that's the case, when you call me, we can change a parameter, we can take it out of the calibration mode, do it manually, and get the machine up and running. So I'm not gonna tell you it's a perfect procedure that it works every single time, but probably, I'm gonna say 96% of the time you're gonna do that, it's gonna work just the way it's supposed to, convert itself, then you're ready to go to the next step, okay? So, after you've done the gas adaptation part, you're gonna do an auto calibration. That's what we're gonna cover here next.
It's time to go through the auto calibration function. This function is a very important part of the commissioning of your boiler. This function should also be done anytime a major component is changed within the boiler, such as the PCB, a gas valve, a sensor, or other components. This is how you set the boiler's ignition, high fire, and low fire heating curves. The auto calibration can take 6 to 10 minutes. To start, open as many domestic hot water faucets as you can. Or, if you have multiple heat loops, turn on as many zones as you can. Next, press and hold down the power reset and the radiator minus button together for about 6 seconds until on is displayed. Then, press the IP button and you are now in the auto calibration mode. You will know you are in the correct mode if the faucet icon and radiator icons flash. The unit will light and display the power of modulation and the temperature in the boiler. Once it reaches ignition, a P and a wrench will display for a few seconds and disappear. The unit will then go into high fire and display 100 and the temperature. Once the P and the wrench is displayed again, the unit has established the high fire curve. It goes back to ignition and then down to low fire. When the P and the wrench are displayed there, the unit has established the low fire curve. When all three settings are found, the P and the wrench icon will remain on the display and the flame, faucet, and radiator icons will all flash. Now you are in the manual combustion mode for 30 minutes. This is when you should use your combustion analyzer to confirm the combustion settings. We will cover combustion analyzer and adjustment options in another video. This completes the auto calibration process and you can exit by pressing the power reset button. ESC will be displayed, followed by the main screen. If you have any other questions, please refer to your installation and user manual that comes in the box.
Auto calibration will also take care of a lot of issues with the boiler, okay? I've had some domestic hot water issues where auto calibration takes care of it. When these came out in 2013 and 2014, before ECR had this technology, okay? The message that was being given by that company was when you commission this, all you did was commission it and you were done. So go through the deaeration, go through the gas adapted part, and you were done, walk away. So when I started working here 6 years ago, the error code I kept seeing all over the place was 53s, 53 error codes. Every machine, I get a call, 53, 53, 53. And if you looked at 53 error code in the manual, it would tell you that was a flue blockage. In 6 years, I've never seen a 53 that was a flue blockage. It was never a flue blockage. It sees it because the combustion isn't right, okay? So it thinks it's not getting enough makeup air back. So it throws a 53 error code. What we found out was, as soon as you auto-cal the machine, 53 goes away. You never see it again. Because with the 53, what the auto-cal actually does is it takes all the electronics in the machine and makes them rethink with each other. So if there was a disconnect, it connects them back again. So now it's working the way it's supposed to, all right? So anytime you do any part change, anytime you clean and service it, when you're done, or besides the commissioning, you're always going to do an auto calibration. And then I always want to do a manual calibration too. I will tell you that here in Ohio where you live, where you don't have any high elevation, okay, 98.9% of the time you're gonna put your analyzer in there and you have to make no adjustments. They're gonna be right where they're supposed to be, okay? And every once in a while you might get one that's a little bit off or you have to make a small adjustment, okay? But for the most part, it should be fine when you test it. How many contractors here have combustion analyzers? Not bad, okay. I see here they sell Field Piece and UEI, is that correct? Okay, nothing wrong. Listen, testers are testers, okay? They all work. The more money you spend on a tester, the quicker response time. And that's where it comes in handy with these machines. Because like every wall hung boiler, they heat up so quickly that if you don't have enough place to get rid of that heat and you overheat the boiler and the burner shuts off, then you got to start over again. Ours is no different. So having an analyzer that reads quickly is going to save you time. Guys will call me up and they'll say, I can't make it stay running. So I tell them, well, purge the system. Purge it all out again, make it full of cold water, then have all the zones call and see if you can get it running. The combis are nice because with a combi, you can just turn on a bunch of fixtures and you can usually get it through the auto calibration into the manual calibration. Okay? So now into the manual calibration.
We will be covering the combustion analysis using a combustion analyzer and the CO2 adjustment function of your boiler. There are two ways to put the boiler into combustion adjustment function. One, you can do it after the auto calibration mode, or you can access it at any time by holding down the Radiator Plus and IP buttons together for 6 seconds until the screen displays on and 304. We are now in the combustion adjustment function. 100% is displayed, which is the firing rate of the boiler. If I press the IP button one time, I can change it to low fire adjustment. 00 is now displayed. We can make CO2 adjustments to both high fire and low fire. Once the burner settles in at the selected firing rate, take the combustion analyzer and put it into the flue by using the left test port at the top of the boiler. Compare acceptable ranges with the chart in the installation and operation manual. The acceptable CO2 range will vary depending on the model. To change the CO2 setting, use the radiator plus minus buttons to increase or decrease the CO2 reading. It's a good idea to print 2 combustion reports. Leave one with the boiler and one for your records.
Now it all seems like a lot, I'm sure, okay? When you think about that, when you're gonna commission it, then you're gonna auto cal it, you're gonna manual cal it. But literally that whole process takes about 15, 20 minutes. You know, and a lot of that you can be doing other things while you're doing that part of it. We're picking up stuff, whatever, to try to save yourself some time. So it is gonna add 15, 20 minutes to your install when you commission this to get all these things done. But they're a super important part of the machine to make sure it's gonna run properly, okay? We talked about the gas valve and how it doesn't, hang on a second. It has 2 solenoids, EV1, EV2. EV1 is an on and off solenoid. EV2 is a balancing solenoid. It opens and closes to increase or decrease the amount of gas going through it. Does it all by itself. Typically when it does that, it's going to increase or decrease, and then at the same time, the fan's going to increase and decrease to keep that 1-to-1 combustion ratio all the time through the gas valve itself. There are no adjustment screws on the gas valve whatsoever, okay? You have the 2 solenoids, you have the pin in the front, and in that manual that I left you in there, if you ever want to test the gas valve, it goes over that in the manual on what you're supposed to have for ohms across the pins to test the coils. Everything is testable in this machine. It really is. And the book that I gave you has a lot of that information in it. And what's not in the book is in the manual that you get in the box as well. Okay? So it makes it kind of nice. We talked about the orifice, taps on the bottom. Okay? There you go. Pins 1 and 3, 20 to 30 ohms. Pins 2 and 4, 60 to 70 ohms. Okay? So voltmeter is important too when you're troubleshooting these. The voltmeter is going to give you a lot of good information. You know, if you're testing a sensor in this machine and you put your voltmeter on there on ohms and it says OL, out of luck, right? So you know the sensor's bad at that point in time. If you're still getting a reading, then you know the sensor's probably okay. All right. Those are just a list of the different parameters you can get. This machine has 800 parameters built into it. You have access to 40 out of the box, and with one parameter change, you can get to 80. You know, most of which you're never going to need. The only ones you really need to know are O2, which is your gas type, and O3, which is your boiler type. Those are the only 2 important ones you're ever really going to deal with as far as parameters go. Okay? But there are a lot of them. So there's just some of your error codes. These are the basic ones that will be in the manual as well. There's a lot more error codes than that, but most of them you're never going to see. There's some weird ones like 385. 384, which is a parasitic flame. Basically, a parasitic flame means it senses a flame that's not there. Weird error code. And the weird part of that error code is every time I get it, this is what's causing it. Is this water pressure switch. Now figure that one out. Try making that connection. The reason this causes that error code, this runs off 5 volts DC. So if that copper pipe starts dripping, like we talked about, and it drips on here and shorts this out, and it's DC voltage, that's what gives me that parasitic flame error code. So, like I said, if you're seeing something out there, I can almost guarantee we've seen it. The company that makes our electronics, a company called Bertelli and Partners, they've been fantastic dealing with any issues that we have and getting us answers real quick to solve those problems. You know, one of the things that I like about ECR is we don't run from anything, we don't hide from anything. If we have a problem, we're going to let you know there's a problem, because anything can have a problem. Okay, I don't have an issue if we have a problem. How do we fix the problem? That's what I want to know. How do we make sure it's not going to happen again? And I think we're really good at that. Okay, annual service. How many people here service their gas-fired equipment once a year for their customers? Awesome. Don't get that in a lot of places. Okay, people think it's gas, burns clean, never needs to be touched. Well, it does. It needs to be touched. Okay, especially if it's propane. Natural gas, much more forgiving. I've gone to houses where the unit's been in for 6 years on natural gas, and I pull the burner out, and it looks just like it did when it came out of the box. You take that same boiler on propane, it's not going to look the way it did when it came out of the box. It's just not going to. Okay. What I recommend, and I tell homeowners and contractors, is you might go to the job site once a year, and you might look through the observation glass at that heat exchanger, and it might be spotlessly clean. That's all right. You can still do a gas pressure test. You can still inspect your vent. You can still do a auto calibration and manual calibration. You can do all those things. Okay. The other thing is too, it's just an inspection. I can't tell you how many boilers I get a call on that are 5 years old. They were never touched. Okay, after they were put in. 5 years later, the machine stops running. The guy goes, pulls the front cover off. This fitting had been leaking, so it leaked down, rotted the pipe, rotted the gas valve, rotted the pressure switch, and it finally got to the point where the machine threw its hands in the air and said, I can't run anymore until that stuff is fixed. If they had checked that machine once a year, they would have found that water leak. Okay? You know, if you go to Europe and you look at heating systems in Europe, they don't put any automatic water feeders in their systems in Europe. They don't put any Watts 911Ss on there or the Caleffi automatic water feeder backflow preventer. They don't. They don't because if they lose water, they want the boiler to shut off and they don't want the water to keep running. You know, when you put a Watts 911S on there and let's say you had a pipe that froze and broke. Well, if you got a Watts 911S in there, what's it going to keep doing? They're going to keep pumping water in until someone shuts the cold water off. I'll never forget, I got a call one night. It was 1 o'clock in the morning. I was still working for a gas company. And we had a house that had a low temperature alarm system in the house. And I was on call, and I got the call. So I went to the office, got the key, went up to the house. I pulled into the front yard, and my headlights hit the front porch, and water was coming down the stairs underneath the door, like a waterfall, right? Well, back then we used to sell, I don't know if they ever had them out here, but there was a company called Trianco, and they sold a boiler called the Heat Maker. And it was very popular in New England. We sold a lot of them. They were kind of ahead of their time, but what had happened was they had buried all the heat pipes in the ceiling of the house, and one froze. And when it froze, it broke, but the automatic water feeder kept pumping water to the boiler, so it kept pumping hot water out through that thing. When I walked in the house, the entire ceiling of the living room was on the floor of the living room. All sheetrock was down the floor. The house was full of steam because it had broke, and water was everywhere. There was like 1.5 inches of water through the entire first floor of the house, and it was a crawl space underneath. So obviously, I just went, shut the water off, shut the power off, and I went home. Because there's nothing I'm going to do at 1:30 in the morning to that house. You know, you're not going to do any more damage to it. So a couple of different ways of thinking about water feeders. We also talked about with somebody, we talked about, you know, adding oxygen. When you add water, you add oxygen, which can also, you know, aid in some of the buildup of some of the stuff in the water that's in there. Now listen, I put them on everything. I'm sure you guys do too. Because you're going to use water over time, especially in a cast iron system. You're going to use water over time. You're going to heat it to a higher temperature. So you want to keep feeding water into the boiler. So we all use them, but like I said, they don't in Europe because they want that machine to shut off. So they don't have the problem with the if it shuts off and they have a little bit of water leak out. So only going to be what's left in the pipe, not what keeps pumping in from the house. So a couple ways to think about it. There you go. That one looks good, doesn't it? Okay, that was probably 6-7 years old, never been touched, and it finally said I can't run anymore. Okay, that kind of buildup is hard to clean. Once you have that kind of buildup on the heat exchanger itself. Just on the flame rod itself? Up in the back there? No, that would probably be okay. As long as it wasn't cracked or broken, I don't get too worried about that. That is not protection of the boiler. What that does is where that fiber barrier is, there's another set of coils behind it. So the fiber barrier tries to keep those coils as cool as long as they can because that should return water, and that's where you can do most of your condensing. Okay, so no, if it looked like this, obviously that's a whole other deal. This one was 6 years. This was 7 years old, never been touched. When the contractor finally got there and made the mistake of sending me these pictures, and it was only a mistake because now he has no warranty because the machine was never touched. You know, so. You can see what it did to the burner, all that fire barrier, and all this buildup here, all this stuff, mineral stuff, is because there was a hairline crack in the stainless steel. When you get a hairline crack in the stainless steel, it doesn't leak until you heat it. Then it opens up and the water comes out in a mist. But when the flame hits that mist, it ionizes the minerals in the water, and it makes that buildup in the heat exchanger itself. Okay, so that's how we knew that heat exchanger had failed. Homeowner was very upset with me. Because he said, well, I have a 10-year warranty in the heat exchanger. And I said, no, you had a 10-year warranty in the heat exchanger. You know, you can't warranty stuff that's not taken care of. You know, if you put in one of these products and in 12 years the heat exchanger fails and you've cleaned it every year, chances are we're just going to give you another one even though it's out of warranty because you took care of it and it should last longer than 10 years. That's another misconception I get a lot. I can't tell me homeowners or people I talk to tell me all these boilers are 10-year-old boilers now. They think after 10 years you're going to have to replace it. I don't know where that thought logic is coming from. Because in my mind, if I just spent $16,000 to have a boiler put in my house and you're going to tell me it's only going to last for 10 years, I'm not going to be very happy about that. Okay? This should be a 20-plus year boiler as long as it's taken care of, without question. If it's not taken care of, then in something like this, then obviously that can shorten the lifespan of that boiler considerably. You know, and then you're going to end up like this heat exchanger is one of the most expensive parts of the boiler. If that's not under warranty, I think your cost in that heat exchanger is about $1,000 for you to buy it before you charge the homeowner for it. Okay, so you know, taking care of it, making sure it's cleaned yearly is going to go a long way in making sure you're covered. Now, if you watch this little video here, let me kill the lights for a second so it's a little easier to see that, I think. When you go to a job site, you're going to look for what I call glowing embers. You see the glowing embers? You look at little pieces of ash, okay? If you see that when you look through your observation glass, it's a good indication the machine needs to be cleaned, okay? And this is what you're going to see when you pull it out. You see all these little spots? All those little spots would be glowing red, like those ashes. With propane, we call that coffee grounds, because that's what they look like. They look like coffee grounds. But if you grab one of those coffee grounds and kind of squish it in your fingers, it's a little piece of soot. That's what it is, okay? You don't see that on natural gas, all right? Just mostly on propane. Natural gas, this kind of green yellow buildup is very common if it hasn't been cleaned for a long time, and that cleans very easily. That's not an issue, okay? But you get that there, you can see that was heat, that was leaking. You can tell because of the buildup there, okay? Now, we do sell a kit. You don't need the kit. I use a toilet brush on all mine. I like a toilet brush. It's got that round kind of head to it. Gets in there really well to clean. I have guys that'll use other cleaning brushes and cut them off and put them in a drill and get it clean it that way. That's fine too. You just want to make sure if you're doing the drill thing that you don't damage this back fiber barrier. If you get the kit, it comes with this little cardboard piece to put back there to protect it. But please don't forget to take it out, because if you forget to take it out, you're going to have a hell of a fire in there for a few seconds. Okay? Comes a glove, cleaning brush. As far as a cleaner, just use some kind of a stainless steel cleaner. We started recommending about a year and a half, 2 years ago, and so does Wiesmann, Citrus Surf 77. Some wholesalers sell it. If not, you can get it on Amazon. It's a citrus stainless steel cleaner. Stuff's amazing. It's all natural, and I use it on my own boiler at my house. My brother has one, I clean his. My sister has one, I clean hers. My nephew has one, I clean his. And I use that Citrus Surf, and I really like it. I used to use CLR. CLR works good too, but if you use CLR, you're just going to put a little bit in a spray bottle and dilute it the rest of the way, because it's a heavy concentration of stuff. And if you use CLR in too heavy of concentration, it leaves a film on the heat exchanger that will actually make it dirtier in the next year than it was before you cleaned it. Okay? You know, the cleaning stuff, I'll never forget. I always worked on the propane side, but I did fuel oil too. You know, I had my silver certificate for fuel oil back in the day. But when I was first getting trained on fuel oil, the guy that was training me in the early 80s, he'd been doing fuel oil since he was a kid, right? Well, back then, we didn't use any test equipment. There's no test equipment. We had the old back rack kits. Remember back rack kits? You flip them up and down 10 times, you pump the top, 15, whatever. He didn't do that. So he's training me how to clean these cast iron oil boilers because we were slow in the summer. So my boss said, I want you to clean some furnaces because we're a little slow on the propane side. So he's trying to teach me, you know, taking a screwdriver off a transformer, you know, is it a half an inch of a bolt coming off there, then that's okay. And then he said, you just got to look at the flame and see if it's smoky. He said, you'll be able to tell. Okay, well, maybe he could tell, but I couldn't tell. And I remember the first 3 I cleaned, a week later we were back because they were stuffed worse, plugged, than they were when I went there to clean them because I didn't know how to adjust smoke like he did, you know, just by visual sight. So the cleaning kits itself, like I said, you can get that, but any kind of a plastic brush, don't use a steel brush, copper brush, don't use those. Don't do anything that can groove the stainless steel. Okay, you don't want to groove it, so keep that in mind as well. But any kind of a stainless steel cleaner will work. You just want to make sure that after you clean it, you got to rinse it, obviously. Okay, we talked about how to take this apart because you already took it apart, and we did all that. Check your spark gap, check your flame rod. It shows a little piece in the end if you wanted to use that piece that's provided. Then you have your condensate trap, and you always want to get that clean when you're done, because you're gonna have a lot of crud in there. A lot of times, a lot of guys on these boilers especially, it just unscrews off the bottom. So a lot of guys that clean them, they'll just unscrew it to begin with, put a bucket underneath there, and as they clean it and rinse it, the stuff just runs out into the bucket and not into the trap. But if you don't do that, just pull the trap off, clean it, rinse it out, put it back together. Then before you put the unit back together, take a couple cups of water and pour it down through the bottom to prime the trap. If you forget, it's not that big of a deal because it'll fill up pretty quickly, but before you get the water in that trap, when it first starts running again, you're gonna have flue gases, coming out into the home. So beware of that. This is showing the kit. When you get the kit, it comes with O-rings and whatnot. I've never changed the O-ring on the burner before. Somebody was asking me how you take the burner apart. If you had to pull the burner out of there, that's, we talked about how you do that. I've never changed that O-ring. Now the O-ring on the burner door, which is right here, I always check that one, okay? I went to a job site where this water, when I got there and opened the door, this plastic switch right here was melted, totally melted into like a ball. And what had happened was, then I saw all this discoloration here on the heat exchanger. Well, somewhere along the line, someone took it apart, didn't tighten these nuts up because they were finger tight, so the air could pass through there. Well, what it did was it rotted that O-ring to the point where it made it fail, and now the flue gases were coming out of there heavy, hot enough that it melted this, discolored that. All this insulation on the side was melted, and the insulation on the front cover was melted. How the house didn't burn down, I'll never know, because it was hot. Okay, so that O-ring, I always check that O-ring too. It's not a, it's a rubber. It's not a rope O-ring. It's just a rubber O-ring that goes to the side. And if you get the cleaning kit, it comes with that O-ring and the O-ring for the burner as well, if you get the kit. Plastic bag, blah, blah, blah. And then, like we said, we weren't done at that point in time because you're going to check your gas pressure, do an auto calibration, do a manual calibration, print out your numbers so you have them.